Hello everyone, welcome back to the third and last day of our event. Yesterday we talked about TypeScript, React, Vue.js, Kotlin and CSS grids, and today we are going into the grande finale covering Microfrontends, Angular and Svelte, and we will kick off the day with a session about sustainable speed. As always, please use the Q&A tool on WeAreDevelopers.com/live to ask your questions to the speakers. It's right beside the live stream. Feel free to engage. The speakers will be happy to answer your questions. I want to say a special thank you to Vinted, our partner of the day, and I also want to introduce you to John Collins, who will be your MC today. He was an engineering manager at Microsoft, Apple and Snapchat, and is now the Director of Engineering at Vinted. So, hello John, how are you? And please tell us a bit about yourself.
Yeah, thank you so much. I'm really excited to be the MC for today and to introduce these wonderful and great guest speakers. So I moved to Berlin around 3 years ago, and now I'm working at Vinted. It's super exciting to be a part of such a fast-growing startup. We're also going to be expanding and hiring a lot of people within our Berlin and Lithuanian offices. And in today's talks, we'll be having a chance to kind of explore deeper into areas that are really relevant towards the Berlin tech ecosystem. So I'm really excited to have a chance to be listening and answering some of your questions today, and then sharing those questions also with our guest speakers. So I'd like to do an introduction to our first speaker today. His name is Mindaugas. He's the head of engineering at Vinted, which is the world's biggest pre-loved fashion marketplace and Lithuania's first tech unicorn. He believes in Vinted's mission to make secondhand the first choice worldwide, and does his best to help achieve it with the powers of caring, listening, and leading in servant leadership. He's also an international speaker. He's a voracious book reader, movie lover, and a fearless software writer. He loves to cook and just an all-around geek. He has his personal experience of leading and managing the Vinted engineering teams, and is a big fan of continuous deployment and releasing code to hundreds of times per day in production. Mindaugas likes to contribute back to the software development community. He's co-founded Vilnius.js, which is one of the longest running tech meetups in Vilnius. And Mindaugas wants to help to improve tech leadership in Vilnius and organizes tech lead meetups frequently. He has made significant contributions to open source with his projects and improvements to existing ones. So excited to have you a guest speaker today, and take it away.
Thank you, John. Hello, everyone, and today I'm going to talk about sustainable speed, as John mentioned. If you get bored during this talk and want to find me on the web, in addition to all the other stuff I did, you can find me on the web and my blog at codingfearlessly.com, or you can find me on Twitter, GitHub, and other social media as Mozūras. This talk is very much related to the company that I work for, Vinted. I've been with Vinted for 8 years now, and no graph illustrates the journey better than this one. And some people ask me, 8 years, that's quite a lot. Isn't it time to look for another job? And to be honest, I feel that I've been part of at least 3 different companies during these 8 years. First, it was a fast-growing startup. Then it was a startup looking for a sustainable business model. And now we're a fast-growing company, a bit more mature, but still fast-growing. And they say that the first part was a fast startup. And from this graph, it might not look that way, but let us quickly zoom in. And in this graph, as you can see, there are Christmas trees, and those Christmas trees do represent Christmas. Then and as you can see, during Christmas, there are a bit fewer transactions on our platform than usual. I guess people decide to spend their Christmas together instead of shopping on Vinted. And as you can see, during these first fast startup stage, during those 3 years, our Number of transactions on our platform went from 150,000 to 1 million. Let's zoom back out. And after this fast startup stage came a more difficult period in our journey. For a couple of years, we were struggling to find a working business model. I won't lie to you, that time was tough. We had to do a reorg at one point, having to say goodbye to 30% of our staff. All wonderful people, all tough choices. That day when we had to say goodbye, I came home completely beat. There were moments too when I was honestly considering saying goodbye to Vinted myself. But eventually, after a couple of years of struggling, we found something that works. And now we are on a fast growth path again. 1.5 years ago, we became the first 1 billion valued tech company founded in Lithuania, a unicorn, how it's often called. While it's been a long journey, I also think that we are only at the start of it. During all those years, we always valued speed. Well, who doesn't value speed, right? Everyone values speed. Fast is better than slow. But the speed we've come to value is not any kind of speed, but sustainable speed. Think a marathon, not a sprint. Sustainable speed is a crucial element of how we approach engineering at Vinted. We recognize the differences between short-term speed and long-term speed. And that sustainable speed is what I'm going to focus in today's talk. I'll deliver the talk in 3 parts. I'll start by outlining how changes affect companies and teams. In the second part, I'll talk about the value of speed in regularly changing environments. And lastly, I'll spend most of my talk giving examples of how we practice sustainable speed at Vinted. So to better understand the importance of speed, it's first very important to understand the existence of changes. So first, let's recognize that there are a lot of things that won't change. So let's start with Vinted's long-term mission. It informs everything we do, and we believe in sustainable consumption, and we want to make secondhand fashion the first choice worldwide. That doesn't mean everyone only uses secondhand, of course. For secondhand to exist, firsthand needs to exist too. Simply means that you want secondhand to be thought of first. So our mission won't change. That was our mission 5 years ago. That is our mission today. That will be our mission 5 years from now. To achieve this mission, we've built a marketplace. In this marketplace, our users can sell and buy items, primarily fashion ones right now. And that is something that also won't change. A lot of other things won't change too. Like in our business, our members will always want to feel safe while transacting. Our sellers will want to sell fast. Our buyers will want the vastest possible selection at the lowest prices, and the fastest possible delivery on the items they bought. But the environment in which we operate will change. Our competitors will. Various technologies like AI, augmented and virtual reality will affect us in unpredictable ways. Our members will pick products and services which, using those changes, will continue to ensure safety, ability to sell, bigger selection, lower prices, and faster delivery. When changes happen, one thing matters over everything else: how fast we are, how quickly we can go from understanding the changing circumstances to delivering value to our members. We also recognize that it's not just about these bigger changes. Changes happen regularly. Well, I mentioned these massive changes like augmented reality. We learn new things every day and have to adjust every day. So because changes are inevitable, speed is what matters. And speed can be a competitive advantage. Fast companies can make mistakes and quickly fix them. fast companies can adopt the ever-changing technologies. Fast companies can match their competitors blow for blow. The slow ones lose. But the importance of speed doesn't mean that we value speed over everything else, or that we want to move fast and break things. That's not Vinted's approach. Breaking things doesn't mean that we would be actually delivering value faster to our members. Most of the time, quite the opposite. Imagine a software engineer. Let's say her boss is putting a lot of pressure on her to deliver to a made-up deadline. If you're an engineer, I'm sure at least once you've been in a situation like that. That engineer is stressed. She spends multiple weeks working insane hours, let's say, and eventually she figures out, well, this is not how I want to work. I have choices. And she picks a different place to work. She quits. Or if she doesn't quit, she spends months being burnt out after this experience. So is that speed? Well, that's not speed. That's not being fast. That might have been a short burst of speed when she worked those insane hours, and I underline might have been. But in the long run, that's a losing proposition. It takes a lot of effort and time to hire a new developer, and I'm sure you're all aware how much effort there is in the market situation with engineering hiring. Imagine another situation. Let's say we release a mobile app, QA engineer reports there is a crash, that we found a minor crash on mobile. And come on, it's minor, it doesn't affect that many members. So instead of fixing that crash in this imaginary situation, we instead continue working on some value-bringing feature. In the short term, that seems like the correct decision, but in the long run, that's the wrong decision, or at least not one we would make at Vinted. Fixing a crash in 6 months after the crash was created will cost more. It will take longer to figure out what's the root cause of that crash. And by making decisions this way, eventually we would end up in a situation where we're spending a lot of our time, a lot of our days fixing crashes created long ago. So these two examples serve as ways of how we think about short-term and long-term, and how we think about short-term versus speeds versus long-term sustainable speed. And I know what you might be thinking, at least some of you. It's easy for you to say, Mindaugas. Vinted is now a mature organization. We can think long-term now. What about when Vinted was a small, fast-growing startup? And in our case, even in those days, we consciously made effort and we consciously made decisions with the long-term speed in mind. That doesn't mean that we didn't do quick spikes to test out new things. We did, but we cleaned up afterward. And to be fair, we had worse awareness of what helps create long-term sustainable speed. There are a bunch of companies that in their quest for speed, those companies create bugs, things to rework, technical debt, and unhappy people. That is short-term speed. That is short-term thinking. And we want the opposite of short-term speed. We want sustainable speed. We're even willing to sacrifice some speed today to be faster long-term. We want to deliver value to our members fast and even faster a year from now. So after discussing the importance of speed, now let's talk about how we practice sustainable speed at Vinted. All of these will be specific to Vinted. There are many things we do to practice sustainable speed, so I won't be able to go through everything. How could I? There will be these will be some of the examples, and hopefully they will help illustrate how we think. I divided this part of the presentation into 3 elements. It's culture, practices, and growth. So let's start with culture. Vinted's culture is built around five statements. We grow, we care, we aim high, we co-create, and we take ownership. In the following example, I will focus specifically on what we co-create. But each of these values connects with sustainable speed. Aiming high is explicitly about thinking long-term, trying to achieve bigger long-term goals. Growing is about long-term. If we'll grow as individuals, we'll be able to achieve bigger things. And co-create also connects with sustainable speed. We believe that individual effort can help in the short term, but team effort is required to achieve sustainable speed. You probably know this quote: if you want to go fast, go alone. If you want to go far, go together. That matches well of how we think about co-creation, teamwork, and sustainable speed. And now let me give a more specific example. So we co-create. At Vinted, we work in teams and we value teamwork. And I've stolen this graph that you now see on your screen from Simon Sinek to illustrate what I mean. Simon Sinek is a well-known author. His book, Start With Why, is quite well referenced at Vinted. And on the left in this graph, you can see the word performance. On the bottom, you see trust collaboration. And trust collaboration is very much linked to teamwork. Now, when Simon Sinek talked about this graph, he used Navy SEALs as an example. Navy SEALs are the primary military special operations force in the US. And this graph is about how they select the right people for Navy SEALs. And of course, everyone, including the Navy SEALs, would love to have someone or their team who's marked here on this graph as green. Great performance, great collaboration. But what about the red person? The one that shows great performance, but is not so great at collaboration. You probably know people like that. We all probably worked with people like that. I certainly did. I think sometimes earlier in my career, I was that person. Everyone says about these people that they're an amazing coder, but they don't really like working with the guy. So Navy SEALs, surprisingly, at least surprisingly to me, wouldn't hire someone like that. And instead, the Navy SEALs would choose someone who's great at collaboration, even if their individual performance is not as great. In this graph, that person is marked in blue. And that's surprising when thinking about the Navy SEALs, because Navy SEALs, any type of military, seems like a very performance-focused organization, individual performance-focused organization. But even they value collaboration very highly. And we at Vinted we do make the same choice. We don't hire these individual geniuses. We hire great team players, and we follow the co-create value in that way. Now, all of that probably sounds great, but how do we actually ensure that the things we value are actually rewarded and actually exist in our company? Because it's easy to plaster nice sounding cultural statements like we co-create on the wall and talk about these statements during all hands. Just saying we co-create during an all hands meeting is not enough. That does not bring it into existence. It's a bit more difficult to actually live these values and ensure that these values are more than just words on a wall somewhere. One way we do it, and we do it in a couple of different ways, but one of the ways we do it is we encode what we value in our growth ladder. You can see this growth ladder on your screen now with the collaboration section highlighted. So at Vinted, we have these stages of growth: and engineer 1, engineer 2, engineer 3, engineering lead 1, staff engineer 1, and etc. And then zooming in on a specific example, our engineers grow through these stages. At engineer 3, we expect the engineer to approach disagreement with curiosity, empathy, humility, and the goal of a stronger solution. So if you want to be hired at an engineer 3 stage, that's something we're gonna expect from you. And if you want to grow to engineer 3 stage, that's something we're gonna expect from you too. There are multiple examples like this in this ladder. So let me give another example. Let's take a look at something that's specific to team leads. People in team lead roles go through engineering lead 1 and engineering lead 2 stages, and we expect those team leads in their teams to build an atmosphere where the team communicates openly with each other without fear. Again, this is something you'll have to do if you want to be hired or grow at Vinted. So we have this culture at Vinted, and this culture connects strongly with the sustainable and long-term speed that we value. And there are specific things we do to ensure that this culture actually exists at Vinted. It's not just something we have plastered on our walls. Now, let's go through some of the practices we use that ensure sustainable speed. So the first thing I would like to highlight is that we use OKRs. And OKRs are the Objectives and Key Results framework, popularized by Google. And OKRs are all about enabling the collaborative and trustful culture that we have. Instead of telling the team exactly what and how we want them to do something, we work in objectives. We agree on objectives with domains and teams, and we leave how they're going to achieve those objectives to them. And there might be situations when in the short term, it would be beneficial to do it differently. Our senior leadership team could be more direct. But in the long term, it's important that we give the responsibility and the room for our people to grow. Giving them the ability to figure out how to achieve these objectives is a good thing in the long term, because they will be able to do it in the future more autonomously. Lean software development is another thing we like at Vinted. It's I've previously talked about through an example with crashes, finding a minor crash in a mobile app, and I've told that it's better to fix something sooner rather than later. And the lean software development, or LSD, principles support this way of action. So lean software development principles are these 7 principles that you can now see on your screen. All of them connect well with sustainable speed. All of them help ensure long-term thinking. Another practice we like at Vinted is choosing boring technology. That probably doesn't sound that exciting, but let me share more details. Think of it this way. Each company has a limited number of innovation tokens. We cannot innovate on everything. It's impossible. We have to prioritize. At Vinted, we choose to innovate on making secondhand the first choice worldwide. We choose to innovate on building a marketplace and on areas crucial to that marketplace, like shipping. To be able to do that, we pick and use technologies that are boring, but boring in the best sense of the word. We don't use the newest, craziest database technology. We use the good old and, yes, boring MySQL. MySQL is well understood. Its capabilities and limitations are well understood. We can soundly at night whilst using MySQL and focus our attention on improving how we ship items to our customers. In the short term, it might be good to use an exciting technology and hire a bunch of engineers who are excited about the technology. In the long term, to keep sustainable speed, it's better to make these boring choices. More excitingly, we deploy our backend web application hundreds of times per day. And we've been doing it this way for at least 6 years, I think. To some, it might seem crazy, but just think about all the bugs we deploy. But we've invested in our monitoring and observability to make sure that we are able to find problems in production quickly. Deploying often also ensures that when we have problems, we can easily identify what caused those problems. So going back to that minor crash example, because we're deploying so often, we can easily pinpoint what caused that crash and fix it quickly. We can be fast. If you deploy rarely, it's not as easy to figure out what caused the problem. We also make a distinction between deploys and releases. Deploying means putting code on our production servers. Release means actually making the code available to our users. So if we have a bigger change that we can't release chunk by chunk, we take advantage of things like A/B tests and feature switches. So we deploy the code into production. Then we test the code in production by flipping a feature switch for ourselves or for our QA. We also run A/B tests for a smaller percentage of our users and see how that particular change affects them. So in that way, we ensure that we are still able to deploy code hundreds of times per day. But when we have to, we cleanly separate what is a release and what is a deploy. All these practices connect with and allow us to keep sustainable speed. They're all about thinking long-term instead of short-term. Now we've talked about culture and practices. Now let's get into the third section, and that's growth. So Vinted has grown a lot over the years. As you've seen at the start of the talk, the number of transactions has increased quite rapidly. The number of people we have in our teams has also increased in a similarly rapid pace. Our engineering team went from 30 people at the start of 2018 to 55 at the start of 2019, then to 110 at the start of 2020. And now we're at 250 people in engineering only. The whole company is even bigger. And we had to make specific choices in how we grow our teams and hire people to make sure we keep the sustainable pace. So first of all, it's worth noting that we at Vinted work in cross-functional teams. So this is also about optimizing for the long term. In the short term, we can have situations where it would seem more optimal to have functional teams. For example, a team filled with only iOS engineers. When you have cross-functional teams, there are days when an iOS engineer might not be contributing to the team's objectives via iOS code. That might seem suboptimal. If you have a functional team of iOS engineers, you can optimize that team's task much better. But in the long term, having a functional team is worse, because then you start accumulating all this overhead of managing projects spanning multiple teams. We ideally want each team to be able to move as fast as possible autonomously. We don't want a lot of cross-team collaborations because they create overhead and a lot of additional project management. We also value that these cross-functional teams work together for long periods of time. They establish relationships and become better at how they work. We don't want to create and recreate teams with every new project. We want cross-functional teams that work together for a long time. But having such long working teams is not as easy when we grew so fast during the last couple of years. So what we did when we had to build new teams, instead of just building a new team from scratch, we built an existing team into double the size of the team and then split that team as equally as possible. Equally meaning similar seniority in both teams and similar tenure, meaning how long they worked at Vinted in both teams. We tried to immediately, after the split, have two well-functioning teams where everyone knows each other and the teams are balanced to perform. This way, we also keep our culture more easily. When you build up a team from scratch, the culture will also form from scratch. We'll even try to keep this principle of growing teams as we'll grow new teams in Berlin, where we've recently started hiring teams as well. Another thing we do to safeguard our culture are tryouts. We have an interview process that's probably quite similar to an interview process in other companies, mostly. First, we have an intro meeting to meet the person, understand what that person is interested in, what we can offer. Then if that person is interested, we ask them to do a homework assignment in most cases. Then we have a technical interview. And we finally have a tryout. And a tryout is a bit more unique to what the other companies are doing. During the tryout, the goal is not to check the technical skills. We already did that during the homework and tech interview stages. And the goal is to check how well you match our culture. You see how you exhibit the values that we have and being with the team. And finally, to stay fast, you might think we don't ever hire junior engineers, and you'd be wrong. Having junior engineers on our teams creates better team dynamics. Anecdotally, senior engineers seem to shape up when they have to serve as an example to more junior engineers in their teams. But more seriously, they also have the opportunity to mentor and grow themselves as they help those junior engineers grow. Growing those junior engineers is a great long-term investment to Vinted's future as well, and a way to ensure that we'll stay fast long-term. That was the last example I've had about how we practice sustainable speed. And so today, at first, I've talked about changes, how some things don't change and some other things do. Then I've talked about the importance of speed and the difference between moving fast and breaking things versus sustainable speed. Then I gave some examples of how we practice sustainable speed at Vinted. I hope this talk inspired you to look at how you can be more sustainably speedy at your company. And thank you.
Thank you very much, Mindaugas. It was a really informative and interesting talk. We're starting to receive some questions, and in case anybody else would like to ask anything, you can go to Slido and use the hashtag WeAreDevsLive in order to ask questions. So some have already started to come in, so I'll go ahead and ask them to you. Suzanne asked, how do you make sure to not over-engineer OKRs?
Over-engineer OKRs. So let me think on how that would look. So our OKR process is, we try to keep the OKRs process quite simple. And we really try to focus on having an objective instead of having the perfect objective. because we believe that it's more important to be aligned than to do it perfectly. So I think it's just a principle we try to follow, and I think that helps us to not over-engineer OKRs.
Great, thanks a lot. The next question that we got to ask is from Peter. He says, do you promote diversity and how do you make sure to be inclusive in your culture?
Mm-hmm. Absolutely, we promote diversity. When I've talked about hiring junior engineers and structuring teams, that each team would have members in their team who are of different seniority, I think that's one way of diversity. But I think any type of diversity helps the team to better solve the problems that the team encounters. So we promote the diversity right now mostly through culture, but we're also looking at the same time to how we can affect diversity in more structured and systemic ways.
Thank you. We got asked from an anonymous person, what's the biggest challenge you face when you're growing your organization so fast that they imagine that it can be quite chaotic?
Mm-hmm. So there were a couple of different challenges. And of course, everything has to do with different types of scalability. So on one side, we had technical challenges where we really had to figure out how do we scale the technologies that we have to handle the ever-increasing load. And it's not just about having more servers, it's setting up the technologies in a way that allows just to add servers. So we had some really big technical challenges on one side, but I think that the bigger challenge was actually the people challenge. And I've talked about some of the things we did to try and successfully scale the teams. And I think we've been mostly successful so far. But I think that the people side will continue to be the biggest challenge over the upcoming years. So recently we've started hiring for engineering in Berlin, and I think figuring out how to, and up until now we've only been the engineering team has only been in Vilnius. So figuring that people part out and how we're going to work between these two cities is going to be a big challenge. We have some ideas on how we're going to do it, but it's going to be interesting when the rubber actually meets the road.
Thanks. We got a question from Ibra who asked, did you have a situation where you needed to change one of the engineering team's tech stacks? And if yes, how did you do that?
Mm-hmm. So we have a couple of examples in our history that immediately jump to mind. One of the examples is when we decided to abandon Backbone.js and replace it with React. I would not be surprised if a lot of companies went through a similar transition. So we first identified, so we looked at all the areas where we have Backbone.js code, and we have identified the areas that are that we change the most, and we started with those, and we migrated the Backbone from Backbone to React in those areas. So one example would be our item page, so where we display the item to our customers. So that was one of the areas we focused first on migrating from Backbone to React.js. And it was, of course, a long transition. And there are still, I still think there are a couple of places in our code where we have a bit of Backbone, but after a couple of years, we're mostly done, and most of our code is in React, and all the new code is written in React.
Thanks. Henrik asked, why did we choose to expand our engineering offices to Berlin and not to another city like Amsterdam?
That's very specific. My guess is he is from Amsterdam. So when we were looking at various cities, we had a couple of criteria. One, we wanted to pick a city where we can hire and build cross-functional teams and domains. Two, we wanted that city to be easily accessible from Vilnius. And that immediately narrows down the number of cities we can pick from in Europe. And then three, we also wanted to look at that market and see how competitive that market is and how we could position Vinted in that market. So when we added all these three ups, we just had a couple of choices. And Berlin stuck out as a clear choice, really. It's easily accessible from Vilnius. There are a lot of great people in Berlin, and not just engineers, but product managers and designers, etc. And while the market is competitive, I think that every market is competitive engineering hiring-wise. We think that we can enter this market successfully and find some great people that would be interested in Vinted.
Thanks a lot. An anonymous user wrote, do we hire remote people? And do you think it's the future of work, having people not be co-located in one of the office locations?
Mm-hmm. I think that, of course, remote will become more prominent as the years go by. But I don't think that is something that will in 50, I'm not going to try to pray 50, let's say in 10 years, everyone's going to work remote. I don't think that's how it's going to work. What we see at our company, at Vinted, and what we see in the industry more broadly is that work from home and hybrid modes of working will become more prominent. So we did a survey recently at Vinted and asked how many of people at Vinted would love to work all the days in the office, or 1 day in the office, or 2 days in the office, or just all the days somewhere not in the office. And the results of the survey were pretty telling. Most of the people, I think more than 90% of the people at Vinted picked a hybrid mode where they spend at least some part of the week in the office. So that's something we're gonna have at Vinted, and we even had that at Vinted before the pandemic. And I think this is the hybrid mode of work will be the most popular even after the pandemic ends. Of course, we're always looking at various modes of working, and if we see that remote is the way to go, I would be, maybe someday that's something that we at Vinted we're gonna implement too. But as of today, as of the upcoming couple of years, hybrid mode is what we're gonna focus on.
Great, thanks. So the last couple of things aren't necessarily questions, they're just comments. There was one is that a lot of people have voted that the part of your presentation about the junior engineers is really cool, that we focus on that. So that's great to hear. There was also another comment about some of our Black fonts on our website. But yeah, overall positive feedback. In our last couple of minutes here, I'd like to maybe ask you a few questions that haven't been asked on the slido.com site. So given that Vinted is the largest tech unicorn in Lithuania, there is tech unicorns that are in Germany or in the UK or in France, etc. How could you explain a little bit about that? Being the largest tech unicorn in a country like Lithuania, like the culture of Lithuania, and how that might be different than other locations.
So first of all, I think that being the first tech unicorn in Lithuania, first it puts a lot of pressure on you because we kind of feel that we're representing the country to the world. Of course, at the same time, it also creates this good feeling that we're actually achieving something that has not been achieved in our country. But in many ways, I don't think that we are already an international company. So while I said that we only had the engineering teams in Vilnius, we already had marketing teams and CS teams in other countries. And some of the people we have working in Vilnius come from other countries as well. So for example, our CEO is a guy from the Netherlands, and he's been living in Vilnius ever since he joined Vinted. So I think that our company is already international, and will become even more international and more diverse as we hire more people in Berlin.
Thank you. My final question is, you've talked a lot about sustainable growth in the presentation. I want to talk a bit about sustainability for our planet. Do you see a role that tech companies have to do for sustainability for our planet?
Absolutely, absolutely. And when I joined Vinted, I'll be honest, I joined for my own personal growth. So I joined as an engineer, and I saw this company as Vinted had at that point just received its first investment, and I thought, I'm going to join this company. This company is going to be growing for the next couple of years, and I'm going to learn a lot, and let's see what happens. But throughout the years, I became more and more invested in the mission and the sustainability part of that mission. I think that climate change and everything related to climate change and the sustainability of our world overall is more and more important to me. And I'm very happy that I work at a company that helps to achieve better sustainability in the world. I think that's an important area we have to continue investing in, and not just Vinted, but overall in the world.
Great, thank you so much. Well, I think we're right about at our time. We're going to be having our next speaker in about 15 minutes, so we'll give everyone an opportunity to go grab a coffee. Just want to say thank you very much, Mindaugas, for giving us a great presentation today. We really appreciate it, so thank you.
Thank you, John, and goodbye, everyone.
hybrid? When you're a chef running a kitchen,
artichokes, please.
Things can change quickly. The branzino isn't selling, the ribeye selling out. My floor manager's wife just went into labor. Getting things prepped beforehand can help you put out fires. Literally. That's what a hybrid cloud approach with IBM can do for your business. It lets you automate processes across all of your clouds to get ahead of problems and earn rave reviews.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hi, everyone. My name is John Collins, and I'll be the moderator for today's discussion. Really excited to be able to introduce Stanimira Vlaeva. She is a Google developer expert for Angular and a developer on the Clarity team at VMware. She's worked on open source projects such as NativeScript Framework, and she loves discussing technology anywhere she can find her fellow geeks. So yeah, feel free to take it away. We're excited to speak with you today.
Hi, everyone. Thank you for joining me. everyone, and thank you for joining me today. My topic today is how to generate code with Angular schematics. I'm a Google developer expert for Angular. I work at VMWare on an open source framework called Clarity. And if you have any questions about the talk or any of these things, you can ping me on Twitter. So what is schematics? I'm going to start with a short definition from the Angular documentation. Just let me remove the Zoom thingy here. All right, so schematics is a template-based code generator, which basically contains a set of instructions that tell it how to transform your project by generating or modifying some code. And this sounds a bit generic. You can basically achieve that with any kind of node script or any bash script, modify some files, add a bunch of stuff. So let's learn what is so special with schematics by first taking a look at the problems that it solves for Angular and for the Angular libraries in the ecosystem. First, the first problem that schematics solves is scaffolding common building blocks. So in Angular, to create a component, you need to add a bunch of files. Usually you need a template file, you need a TypeScript file that contains the class for the component. You also need a CSS file, maybe some tests for this component. And then when it comes to adding the usual component class, it's all component classes for Angular look pretty similar. You have a metadata with some selectors, you have a constructor, ng-on in it, some other lifecycle hooks, basically a bunch of code that looks pretty similar. Also, you have to register every component inside a module. You have one root module, this is going to be the app module. If you have feature modules, you have to register the components inside your feature module. I'm pretty sure you're all familiar with that if you touched Angular at some point in your life. So what am I saying that? Imagine a world where you had to do all that manually. That would be pretty confusing and annoying because it's a lot of code, a lot of files that are very repetitive. Luckily, of course, you have to do the same thing for modules as well. You have a very similar repetitive code that you have to add. But luckily, the Angular CLI provides us with the engine generate command that can help us generate components and modules and services and all the other common building blocks for Angular. And you don't have to do that manually. We will see later that underneath, ng generate uses schematics to achieve this. Other problem that is solved by schematics is the automatic generation and configuration of libraries and features. I mentioned that I work for in a project called Clarity, and this Clarity has an Angular package, which means that Clarity can be used in an Angular project, and it's basically used across all VMware, and VMware has lots of Angular projects. So how do you configure the Clarity package inside your application? First, you have to install a few dependencies, save them in your package.json. Then you have to configure some styles and scripts inside the Angular JSON file. Then you have to register the Clarity module inside your root components or root module or inside any feature module that you want. And as you can see, this is very simple and repetitive and well-defined process in terms of steps. But if you have to do that daily on a bunch of new apps, or if you have to do that even once, if you just want to try out Clarity, it might be good to have that automated. Luckily, the ng-add command that is provided by Angular, and it's extensive, it can be extended by any Angular library, allows you as a library developer to define a set of instructions that help you configure the project for your users. So what we see here, we're executing ng-add CLR Angular in some Angular project. This command does all the steps that we did in the previous slides automatically for us. We have the package.json updated, we have the Angular JSON updated, we have the Angular, the quality modules registered inside the app module. And this was defined by the quality team inside our library. So it's not something that comes out of the box with Angular. Similar example is how you would make your Angular application a progressive web app. First, you need a whole bunch of icons that you have to generate based on one icon. Then you need a web manifest file that describes some stuff for your project. Then you need a service worker file that is also very well defined, but you have to add that manually to your project. Then you have to add some dependencies. You have to add something to the Angular JSON, very well defined steps. Luckily, there is ng-add for Angular PWA as well, which when you execute it inside your project, does all the configurations that we saw automatically. It generates icons, it does all these repetitive steps that you don't have to do by yourself. And this is basically making it easier for users to start using your library or your feature. How about migrating rating changes? If you are an Angular developer, you know that between every feature version of Angular, every major version, there might be some breaking changes because Angular is following the VMWare format for releasing. Every major version of Angular can bring breaking changes that basically you have to adopt to make your application work with the newest Angular version. The Angular team provides the ng update command that you can execute inside your project, and it will do all the necessary replacements so that your project works with the latest version of Angular. And as you can see here, this is updating your dependencies to the latest versions of Angular. Then it's executing certain migrations that were defined inside the Angular library. So to summarize, these are three Angular CLI commands: ng-generate, ng-add, and ng-update, that makes life easier for us, and that internally use schematics. But the cool thing is that you can actually write your own schematics, and they don't have to be attached to the Angular CLI. So the schematics library was developed by the Angular team, but it is not really attached to the Angular framework in any way. It's open source and it's pretty extensible. So you can write your schematics scripts and use them in a React application or use them for any kind of task that you want. They're not attached to the Angular framework in any definitive way. So there are a bunch of collections for schematics. These are packages that pack certain scripts inside of them, and they distribute the scripts, and the Angular CLI or the schematic CLI can use them. The default collection for Angular projects is called schematics Angular, and this is what you do when you generate. This is what you use when you generate components, ng modules, services, and so on. There are also schematics for ng arrays that can help you generate actions, reducers, and all other things related to ng arrays. And as I mentioned, we also have quality schematics. So these are all third-party schematic collections that weren't developed by the Angular team, but still can be used with the Angular CLI. And why do we need to use schematics? Why don't we write just our generic scripts that can update files and generate files? Apart from the fact that schematics can be used through the Angular CLI, so you can have your own ng-generate components or your ng-generate custom component, we have a few other features inside schematics that might make us want to use them. The first one is the atomic updates that are provided by schematics. So if we decide to update this project structure without using the schematics library, and we decide to go with a node script or some bash script instead, we might write something like the following. First, modify the package.json. For example, add a new dependency inside it. And the package.json is going to be modified. Then create an app module.ts file. And at this point, we see that in the file structure, we already have this file. So we're going to get an error. And the current state of the directory is going to be that the package.json is modified. And that is not exactly the desired result because we are in our migration or our modifier script failed, but the project was still modified. And at this point, the project might be broken because we haven't executed the instructions till the end. And instead, we have some kind of rollback strategy that we customly wrote in our script. This is going to be the default behavior. But with schematics, these actions are actually executed on a virtual file system. So we're going to have the modification for the package.json, then we're going to have the creation of app module.ts, then the schematics engine is going to apply this on a virtual file system, which is actually a representation of our current state. So it looks exactly like our current directory, but it's just a method to prevent these half-broken states. So we're going to see that when we're applying all these actions to the file system, to the virtual file system, we are going to get an error. And schematic is not going to apply any of these changes to the actual file system because we have an error. And the package.json file won't be modified. And this is good. And that's why we're saying that schematics performs atomic updates. Basically, every set of instructions is transactional. Also, schematics are composable. You can use all schematics defined by the Angular team for module services and so on, or any other library in the Angular ecosystem. They're also pretty easy to unit test because you write actual code with TypeScript to define your instructions. And another reason for this unit testability is the fact that we're working on a virtual file system. All right, let's see how we can get started in the easiest and most basic way. We're going to have a bunch of code here, but if you're not familiar with Angular, don't worry about it. It's just a generic TypeScript code. And if you're not familiar with TypeScript either, it's just a basic superset of JavaScript. And we're not going to be doing any too fancy TypeScript things today. So we're going to see a lot of code snippets. I'm not going to do any live coding because I don't want to bore you to death. So let's get started. The first thing that we need is the schematic CLI. This is going to allow us to easily move forward, create new scripts, and test them. And we're not going to basically wrap or tie our collection to the Angular CLI today, but you can check out the Angular documentation on schematics, and it's explained how you can do that there. So first, we're installing the schematic CLI, and then to create the new collection, we have to execute schematics blank and provide the name of the collection. And inside this collection, we have only 8 files. Half of them are package scripts that exist in any JavaScript project, or in this case, TypeScript project. And the other half of them is the collection code. So let's take a look at the collection.json file. This is a schema that defines all the scripts inside our collection. And currently we have just a single script, which kind of confusingly matches the name of our collection, and is called my collection. And here we have description that is not very meaningful right now, and we have a factory key. Let's see where this will lead us. When we go to the factory function, we see that we have a single exported function called myCollection, which returns another function, which returns a tree. And this might look confusing, so let's go ahead and take a look at how schematics, how the schematic scripts work. So the most important term in this library is called tree, and the tree contains a base, which is our current project, a kind of a snapshot of the directory that we're in at this current moment. And this current moment is the moment when we are executing the script, and a set of actions that should be applied to that base. And a rule is a function that takes a tree and returns another tree. And the new tree might have some additional actions that should be applied. And a rule factory is a function that returns a rule. Hence, it's a higher order function. And basically, it's a function that returns a function that takes a tree and returns a tree. And this is what we see in this hello world script. We have our rule over here, and the rule factory is the outer function. When we execute that with schematics, actually, this is how we add a new schematic. So we're just going to add a new schematic called say hi so that we don't get confused with the myCollection script. And to start using this project, we need to run npm install and then start the TypeScript compiler in a watch mode. This will basically transpile all the TypeScript files to JavaScript, and then we're going to execute these JavaScript files with Node. So we're going to invoke the schematic CLI again. We provide dot because we're going to be using the collection that lives in this current directory. Then we have colon, and then we have say hi, which is the name of the script. And currently there is nothing to be done because the script is empty, doesn't do anything, any modifications to the tree. So this is what the schematic CLI is going to print. All right, let's see how we can log messages and provide options to our scripts. In the inner function, we have tree, and we can also have another argument called context. And in this context, there is a logger that we can use to print stuff on the console. We can print it in errors, info messages, we can print debug statements, anything we want, similar to console log. And in the outer functions, we accept options. So these options can be provided to us through the command line when we are invoking the schematic script. And basically here we are providing the option name, and in our script we're using the name to log it. Nothing really fancy. On to the more interesting stuff. How do we create new files? Most of the tree modifiers live in that tree object as well. So to create a new file, we need to invoke tree.create, provide the name of the file, and then the content of the file. So when we execute that, and when executing it with the schematic CLI, we also have to provide debug false so that the changes are actually applied in the file system. So when we execute it, we are going to get a new file which has the content that we provided. And as you can see here, the docs directory might actually not exist. So schematics is going to create that directory for us, and it's going to put the file inside. We don't have to take care of that. Renaming and moving is actually happening with a single method on the tree object called rename. So we can provide a new path or a new name for the file that we want to rename or move. And when we execute that, we are going to get a new file with the exact same content, but with a different name. All right, we covered the basics of schematics. Now you can do some very, very simple things like moving and creating new files. But let's move to the more interesting stuff that the Angular CLI also uses internally. And the first thing is composition. I mentioned that earlier. You can compose different scripts that even live in different schematic collections. So you can take the Angular component schematic and execute that inside your project, and then take these files and do some modifications on them. So you might want to have, I don't know, an additional file next to all your component files in your project. So you can do that with a schematic script, and you can start using that inside your project instead of the default in your collection. So to do composition inside your scripts, first you need to import the schematic rule factory. That is an util method. That's an util function that's exported by the Angular devkit schematics package. And then you can execute any schematic from your own collection by specifying the name of the schematic script, and then you can also provide some options. And then to do actual composition, you have to use the chain utility, and basically you can return chain and add in an array a different set of rules inside it. So first here we're executing the schematic say hi, and then we are creating a new file. So this is a composition of two different scripts. And when we execute that, we're gonna get hi Florence that was executed by the say hi script, and then we get a new file. And if you want to do that with an external collection, you just have to use the external schematic utility instead of schematic. It lives in this package. You will find it easily if you look for it. And now let's go to templates. I will give you an example of a template in the next few slides. But first, just to get you to wrap your head around why we need templates. You remember the component that we saw in the first few slides. So there we had a bunch of similar files, the name.component.ts file, the name.component.css file, the HTML file, which also contains a template for the component. We had the test file, and these are all the same and basically look the same for every single component that is created. And if we further take a look at the class, there we have exactly the same TypeScript class with exactly the same metadata with a few differences. Just the name of the class is different, and also the path to the template is different. But other than that, every single component that is created by the Angular CLI is exactly the same. And the Angular CLI uses a template for creating these 4 files every time you use ng-generate components. So let's see how we can use templates inside our own collection. First, we can, so this is going to be our script, templating schematic. And our template is going to live inside the files directory. And here we have a single file in this weird format, and that file name is going to be replaced by an option provided from our script. And here we have a simple templating language that I'm sure you can understand what it means. We can have conditional statements. We can have interpolation. So we're going to replace breed with the actual breed argument that is provided by the script. And this is basically how this template looks like. If you need to create your own, just go ahead and take a look at the Angular CLI templates, and I'm sure you will understand how this simple language can be used. And now applying the template can look a little bit weird. So we have merge with, apply, template, which doesn't make any sense to me at all if I see it just like that. So let's take that and break it down in different steps so we can understand what's happening. And yeah, this was my reaction when I saw that first. So you remember that we have the row, which is a function taking a tree and returning a tree with new actions. And a source is basically a function that doesn't take a tree, and it creates a tree from some source. And a source factory is a function that returns a source. And just to make that a little bit more clear, we can have the URL source factory, which takes the files directory, and it creates a new source out of that. So basically, while our script is running, we are creating a new source that will return a new tree with a bunch of actions. So whenever we invoke files, we're gonna get a new tree, which doesn't have any base. It has no base at all, but it has a bunch of actions that are all create actions for every single file that lives here in this files directory. And let's see what happens over here. We have the URL source. This is gonna create a bunch of actions for creating the files inside this directory. Then we have the options that we wanna replace. So our file name is gonna be breed statement, and then we're gonna have a breed of Cocker Spaniel. Then we get a template rule by applying the template rule factory to these options. And then finally, we apply this template rule to our source. So we get the files over here, and there are the template, and we apply these options to them so that we get all our content replaced in the proper way. And finally, we use merge with, and you might be wondering, as I was, what do we merge with? And actually, this is gonna merge the newly generated source with our current tree, which I don't know, why wasn't that just merge with tree and then source? I don't know, but basically you use merge with to actually apply these newly created files to your current structure. All right, so this is how you use templates. If you ever have to do that, just create a new utility function, paste that code inside, and don't ever think about it again, so that you don't have to write that from scratch. And when we execute the templating schematic, our file name file, our template is going to be converted to an actual file, and we're going to get this content inside. All right, on to the next pretty important thing. I'm not giving you too much time to take a look at the code or even try to remember it. I hope that you understand the things that we're explaining, but don't worry about it. You can find these slides later if you want to check something, or if you see something that's missing or weird, you can always ask me on Twitter or anywhere you find me. But again, that's not what's important. The more important thing is to get your head around what you can actually do with schematics, and think about how you can maybe apply this to your project or your library that you're working on. So again, the final thing that I want to show you is how you can modify files. And this example is something that we consider doing for the Quality library. Basically, when you install Quality in your project, you don't have it, I mean, you have it set up, but you don't have any sort of Quality layout. So the idea is to take the app components, if this is a newly created project, remove its contents and replace it with some layouting content that is provided by Quality, and it contains some basic Quality components inside. So what we're doing here, we have the component path, this this is the default for Angular, but there are way better options how to find the entry component. Then we read that with tree.read. If we don't have an app component, basically means that this path doesn't exist. And then finally, if we actually have an app component, we can use tree.overwrite to replace the current content with the content that we want. Let's take a look at how this works. So here I have my demo application, which is basically a newly created Angular application. You have all seen that if you have ever created Angular app in the past maybe 2 years. And what I want to show you is what happens when we execute our query layout script. So again, I'm using the schematics CLI. Here I'm providing the path to the collection, which lives in schematics demos, then the name of the schematic, and again, debug file so that the changes are actually applied. I'm gonna execute that. And when the app refreshes, you see that the app component file was, content was replaced with some actual query layout. All right, this is the short thing that I wanted to show you for a demo. And if we go back to the slides, please stop moving. Okay. I actually don't have any more demos. I just want to show you a list of resources that you can use, and also a link for the slides, so you have access to these resources. I'm going to stop sharing my screen just for a second so I can restart the presentation and show you the list of resources. All right, I didn't lie to you. This is the previous slide. So we are now on to the resources slide. Here I provided you with links to the Angular IO documentation about schematics, which is very well written, and you can find out a lot of information about how to use schematics in your library there as well. The demos that we saw all live in this repository on GitHub. Here are also links to a couple of schematic collections that I've worked on. This is the quality schematics that I also have to thank my teammates on the quality team for initially writing. I just refactored these, so I haven't actually added anything new there. And these are the native script schematics, which take that approach of extending the default Angular schematics and adding on top of them. So if this is something that you're interested in, check them out. And for quality, if you're interested in ng adds or ng updates, we have a bunch of migration schematics and also ng add schematic there as well. This is my Twitter handle and also a link to the slides, which contains all the other links inside. So I'm going to give you a moment to write that down or follow me on Twitter if you want to. So this is everything I wanted to share with you today. Thank you for your attention, and cool. I hope to see you soon, and ask me any questions in Slido if you have any.
Great. Thank you so much for your presentation today. Really appreciate it. I think it was really informative for our listeners. We actually just got a bunch of questions coming in. So we have around 10 or 15 minutes or so that we have time for questions. So I'll just start sharing these. The first one is from an anonymous user. Is it true that it also works with reactive view?
That schematics, sorry, is it true that schematics also works with reactive view. Oh, okay, I see
Yeah.
that. Yeah, you can write any type of generators or scripts and then execute them through the schematic CLI. So it can be any kind of project at all. And I believe there is also a collection for React, but I might be lying. Just Google that if you're interested. I'm sure I saw that somewhere in the past.
Thank you so much. Next question that came in is from Pret. Why do you use TypeScript?
TypeScript is basically the language that it has been adopted by Angular very early on, and the whole Angular framework is written in TypeScript. So they have also decided to write schematics in TypeScript. So this is a very generic answer. So why do you use TypeScript in general? I guess for type safety and other things.
Great, thank you. Next question that came in is from Dino. How do we implement an event listener?
I'm not sure what that question means. Maybe, Daniel, if you can specify a little bit, what kind of event listener do you need?
Okay, we'll skip that one and maybe come back if there's some additional comments on that one. This is from an anonymous person. Is it true this is working with Vue and React? Maybe.
Yeah, didn't we cover that already? I think that was the first one.
Okay. Next question is from Cleo. And how do I become a GDE?
So that's a very good question, but it has a very long answer. I can probably direct you to a bunch of blog posts that the Angular team and some GDs wrote. But in general, you have to be active in the community that you're in. For example, if you take the Angular community, you have to be active with helping different people, doing talks about Angular, educating people about the framework, basically spreading the word about Angular or any other category such as Flutter, Android, or I don't know, Cloud. And then you have to be recommended by another GD. And then there's a whole process that you have to go through. But a good first step is read the blog post about becoming a GDE, and if you are eligible, or eligible is not the right word, but if you are active in your community and you're helping people, then you can become a GDE.
Thank you so much for that. I think that concludes our list of questions, but if anybody else has any questions, you can visit slido.com and use the hashtag WeAreDevsLive. There was a few pieces of feedback from anonymous people that they really appreciated your talk. So thanks a lot for that. Maybe while we're just waiting, in case there's any further just final questions, would you mind speaking for maybe just 1 or 2 minutes about VMware and about your experience there and your journey at your company?
Yeah, sure. I actually joined VMware last year, and I work on Clarity, which is a design system that design system and also components library that all VMware uses internally and is also used externally because it's open source. Actually, there's something interesting that we're currently doing in Clarity, which is we are rewriting our Angular library to use web components so that it's new, up-to-date, very accessible, with accessibility ingrained inside that new web components library. And it can also be used in React, Vue, and of course Angular, because Angular is a very integral part of all of VMware.
Great, thanks a lot. And while you're giving that answer, there was a comment or a question from Stratos with 3 upvotes saying, what are some real life scenarios of using templates like these and how can we use it in our day-to-day life?
There are different options. I mentioned the NGRX library. they have created their own collection for generating actions and reducers. In NativeScript, we use them for generating NativeScript components. Something that I came up like an idea of some time ago was generating a service that has some basic API calls inside it, basically crude calls. So instead of having the default Angular service, you have a create, updates, deletes, or whatever methods that you would normally use in your project. What else? There are many options.
Sounds good. Well, thanks a lot for answering the questions. There's nothing further on Slido. We want to thank you very much for taking the time to speak with us today. It was very informative. So thank you very much for your time.
Thank you. Bye.
job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Why should your business go hybrid? Here's the beauty of a hybrid cloud approach with IBM. Your data, apps, and clouds all work together in concert.
There's never pressure what to do to it. Carolina Diamonds got
so you can make something that's never been heard before. I like that.
I do it for us to be exact. All the applause off of the cause, yeah, off of my...
Hi everyone, it's a pleasure to be speaking with you again today. I'm your moderator, John Collins, and I'm really excited to be giving and introducing our next guest speaker. His name is Manfred Steyer, and he is going to be talking with us a bit about Angular. So to give you a little bit of background on his bio, he's a trainer, he's a consultant, and a programming architect with a focus on Angular. He's a Google developer expert, GDE, and he's a trusted collaborator in the Angular team. He writes for O'Reilly, the German Java magazine, and Windows.developer. He's a regular speaker at international conferences. So thank you very much for your time today, and I'll hand it over to you.
Yeah, hello and thanks for having me. This presentation will be about Microfrontends with Module Federation and Angular. And I really like to start with this picture here. Perhaps you know this picture. This is the helicopter developed by Leonardo da Vinci. Perhaps developed is not the right term because he only constructed it, because he lacked of the right material for building it. But the thing is, back then in 1400 something, he really constructed this helicopter. And nowadays, scientists obviously have the right material for building it, and they build it, and they found out it really works. It really flies. How cool is that? And somehow this very story reminds me to the current situation of Microfrontends, because the idea is everything but new. The idea has been around for several years, but so far we didn't have the right material to build them. We needed to work with a lot of tricks and workarounds, but this is changing now with Module Federation, which is a straightforward solution for building Microfrontends. Well, what do I mean when I use the term Microfrontend? Well, at the end of the day, a Microfrontend is just a tiny frontend. The idea is to subdivide a big application into tiny parts. And all those tiny parts can be developed by different teams. That means those teams can be small and have a lot of agility. And they can just publish it when they are done to provide additional business value. This also obviously reduces the overall complexity. But on the other side, somehow we need to load all those Microfrontends into something I'm calling a shell, because the user is not happy about having 50 frontends. The user just wants to have one integrated solution, and this is our shell. This is exactly what you see here on the screen. On the left side, you see a Microfrontend, a little tiny frontend that has been developed and deployed in isolation. And on the left side, you see the shell that is loading this Microfrontend on demand. As mentioned before, in the past, we needed a lot of tricks for doing something like this, for loading a separately compiled application into our shell. But nowadays, we have Module Federation, which really makes this task easy. And this is what this whole presentation is about. In this presentation, I want to give you an overview of Module Federation. Also, I want to talk about version mismatches. I want to show you how to deal with version mismatches that can occur at runtime when loading different applications into a shell. Furthermore, we talk about federated Angular, which means we will look into combining Module Federation with Angular and the CLI. And at the end, I want to present you a possible roadmap. But first of all, let me introduce myself. I am Manfred. I am a trainer and consultant for Angular. I'm doing a lot of in-house trainings currently because of the current situation. Those in-house trainings are done remotely. And besides this, I'm quite connected to the Angular community. Perhaps you hear it at my accent. I live in Austria. I do a lot of stuff in Germany, and I'm always happy if I can work together with people around the world. Okay, so let's get started with the first thing I've prepared for you. It's a general overview of module federation. The basic question module federation tries to answer is this here, namely how to load separately compiled, separately deployed code. And perhaps you are saying now, hey, Manfred, come on, that cannot be that difficult because we have dynamic imports nowadays. And even before we had the require statement. So why not just use a dynamic import or a require statement to point to a separated compiled and deployed application in order to load it into our shell? Well, the thing is, in theory, this works perfectly. In theory. In practice, this doesn't work at all because of how all the builders and bundlers are working. For instance, if we look into Webpack and also into CLI using Webpack, we see that everything needs to be there upfront. Even the lazy parts need to be upfront available. Everything is compiled together, everything is optimized together. Think on tree shaking, for instance, and then and only then everything is cut into chunks for the purpose of lazy loading. But for us, this is too late because we don't want to know everything upfront. We only want to know the microfrontends at runtime. We want to load them at runtime into our shell. And this is what module federation tries to solve. For this, module federation introduces two roles. The first role is called the host. The second role is called the remote. For us, the host is more or less the microfrontend shell, and the remote is the microfrontend itself. Using the Webpack configuration, you can configure both roles. For instance, you could map an URL for the shell. You could say, hey, each and every URL starting with MFE1, which stands for Microfrontend1, points over there to a separately compiled and deployed microfrontend. And by the way, over there, it's also called MFE1. That means here I could define an alias, or like I did here, a non-alias. MFE1 points to MFE1 over there. Over there, within the remote, I can expose files. I can say, hey, let's expose this TypeScript file with, let's say, a component or an Angular module, or even just a function. And also exposed files get a nicely mapped name. And now something beautiful happens. I guarantee you, you will love it. Now you can use a dynamic import with those mapped paths to point over there to load something from over there. And this is really beautiful because Angular does not even recognize that we are loading a separately compiled microfrontend. For Angular, this is just traditional lazy loading. Of course, Webpack underneath the covers knows that we are using a mapped URL, and that means that we want to load something from over there, meaning Webpack is doing the heavy lifting for us. But Angular itself does not even recognize, nor does React or Vue or your framework of choice. And that means you can use your high-level framework as it was intended to be used. You don't need some additional meta frameworks for orchestrating different microfrontends. Just go with your framework as is, like Angular, and you are fine. Of course, we need some metadata about the microfrontend, and this metadata is generated by module federation when building the remote. The name of this metadata file is called remote entry, and you need to load it into your shell. You need to load it up front so that the shell knows how to interact with this microfrontend, how to load it, and how to share dependencies with it. Talking about sharing dependencies, this is also another nice feature of module federation. It allows you to define dependencies that shall be shared across all your microfrontends. So in my case, I obviously want to share Angular core. I just want to load Angular core once and then share it across all the microfrontends. This is really vital here, because having 10 microfrontends does not mean that I want to load Angular 10 times. That would be quite an overhead, wouldn't it? And that's why it's good to instruct module federation to share this or that library. Of course, now the big question is, how can we combine all of this with Angular itself? We want to use this together with the Angular CLI and obviously with Angular itself. And for this, I have a good message for you. The Angular CLI is already using Webpack underneath the covers. That's the good message. But there is also a bad message, namely the Angular CLI is shielding Webpack from us. Well, normally this is fine, because honestly, we touch directly with Webpack. It's quite complicated, and so it is good that it is normally wrapped by the CLI. But in this case, this is an issue, because now we have a module federation config, and somehow we want to squeeze it into the Webpack configuration underneath the covers. That means we need to find an official way of doing this. And this involves using custom builders. A custom builder is something like an exchangeable strategy for the Angular CLI. The Angular CLI does not directly use Webpack and all the other tools. It is using it in a loosely coupled way by doing an indirection via builders. The default builder provided by Angular is using Webpack for applications. And what we can do now is we could now provide a custom builder that is delegating the module federation config to Webpack, and then it can delegate to Webpack. Then it can tell Webpack, now you have the config, please do what you are always doing, please build this very application. And hopefully Webpack will say, yes, I'm building this application respecting this very module federation config. So at the end of the day, such a custom builder is just a matter of, let's say, 10 lines of code, give or take. And of course, you need to use some boilerplate around it to make it be usable as a builder by the CLI. That means you could handwrite something like this, but you don't have to, because I've already done it for you. You can use this existing package I'm providing. It's called Angular Architects Module Federation. And basically, this package is doing 3 things for you. First of all, it generates the skeleton of a module federation config. That means you don't need to learn this configuration by heart. You get the skeleton, you just have to fill in placeholders. That's the first thing. The second thing is it installs a custom builder for you, enabling module federation underneath the covers. And the third thing is it assigns a custom board for ng-serve. This enables you to ng-serve your microfrontend side by side for testing and debugging purposes. What do you need to get it? Well, you just need to ng-add it to your application. And then, of course, you need to adjust your generated Webpack configuration. And after that, you can ng-serve your applications, your microfrontends, and you should be fine. That's more or less everything. And for this, I have prepared a demonstration, because I'm always saying module federation and microfrontends are a bit like the 1980s, you know? You have to experience them to know what they are about. That's why I will show you everything here in action. Okay, let's have a look at the demonstration I've prepared. What you see here is a microfrontend shell. And what you see there is my microfrontend. You can see it by looking at the dashed red border. It is the border around my microfrontend. And as you see here, both of them runs on different origins, on different boards. This is not a prerequisite. It is not. But in my case, this is proving that I'm dealing with two separately compiled applications. And now when I'm clicking on flights, then we see that nothing works, because now this is my task during this demonstration. My task is to load the separately compiled and deployed microfrontend into this very routine. For this, let's have a look into our source code. Here we see a monorepo. You don't need to go with a monorepo. You can also go with several separate repositories, but for this demonstration, going with a monorepo is a bit easier for me. And this monorepo consists of two applications. Here is my shell, and there is my microfrontend one. If we look into the package JSON, we see that I'm already using CLI 11, which is fine because this is the newest version. Well, frankly, the newest version is 11.2. something, but 11.0 should be fine, I guess. That's the good message. The bad message is CLI 11 is still using Webpack 4. However, we need Webpack 5 for module federation. This is somehow an issue. Why is that? Well, the thing is, CLI 11 and Webpack 5 have been published at about the same time. There was not enough time to integrate Webpack 5 into CLI 11, and so the Angular team decided to stick with version 4. Because it was heavily tested and they knew it works. But for CLI 12, which is due in May, give or take some weeks, it will be integrated, meaning CLI 12 will ship with a fully flagged Webpack 5 integration. But I also have a good message one more time for you, namely, because of some community contributions, it is already possible to use CLI 11 together with Webpack 5. It's not officially supported, but there is an experimental opt-in. And it works quite fine for testing and prototyping. To opt in into Webpack 5, you just need to add this segment to your package JSON. This segment tells the Yarn package manager to force everyone into Webpack 5. Regardless which Webpack version they are requesting, they get Webpack 5. This works with Yarn out of the box. That's why I would recommend you to go with Yarn for this. And there are also some additional packages for NBN. When everything ships with CLI 12, you don't need this workaround anymore. But for the time being, please keep this in mind. Meanwhile, I have already installed everything with Yarn, meaning I have CLI 11 plus Webpack 5. And now let's activate module federation for my example. For this, I'm jumping to my console. Here I have one tab for my shell, and here I have another tab for the Microfrontend one. So let's clear the screen, and let's start with the Microfrontend one. I'm adding this plugin, Angular Architects Module Federation. Now, of course, it's downloaded, and then it asks me, which application do you want to enable for module federation? And here I'm saying, hey, I want to enable my Microfrontend one. And by the way, for debugging purpose, I want to go with port 3000. Now, some files are generated and other files are updated. For instance, I'm getting a Webpack config generated. I need this configuration file for adjusting how module federation works. Plus, within my Angular JSON, the custom builder, which is enabling module federation underneath the covers, is registered. I'm doing the same with my shell. So let me copy this. Let me move over here and let me do the same for the shell. Now I say, let's enable the shell for this, and let's go with port 5000. And the same stuff happens. Now let's have a look into the source code. If we look here into the source code of my Microfrontend 1, we see a traditional Angular application. It is nothing special in there. It's really a traditional Angular application. The only thing that's a bit different is we have now this Webpack config file. This Webpack config file that has been generated by the plugin. But you don't need to worry. This is not a fully flagged Webpack configuration. It's just a tiny partial one. A partial one just containing all the stuff we need for module federation, which is first and foremost our module federation plugin. And now we just need to adjust it. Here we see two sections. The first section is for Microfrontends. The second section is for the shell. And as I'm talking here about the Microfrontend 1, we will keep the first section and get rid of the second one. So here in the first section, I can assign a name to my Microfrontend. I can even assign the name for the remote entry file. You remember, this is the file holding all the metadata for the shell. This needs to be loaded into the shell so that the shell knows how to interact with this very Microfrontend. Under exposes, I can expose files for the shell. So here, let me expose a module. It's called the flights module, and it's located in the flights folder. If we look into this flights module, we see a traditional Angular module, nothing special in here. A traditional Angular module providing some child routes. That means I can directly jump into those routes when loading this Microfrontend using module federation. If we proceed with the configuration file, we also see that we have here a shared section. Using this section, I can share libraries like Angular Core, Angular Common, and the router itself. And with the configuration here, I can define how to behave when there is a version mismatch. For instance, a version mismatch would occur if someone is providing Angular 11 and someone else is providing Angular 12. In this case, we have two different major versions, which is obviously an issue because loading two different major versions of Angular is probably not a good idea. And in this case, this configuration is just emitting a runtime error. Fail fast is here the motto. Fail fast, because if we are mixing different Angular versions, we could end up with some issues during runtime. We want to prevent this from the user. There are also other settings. Module federation is quite flexible when it comes to configure it regarding its behavior when version mismatches show up. You can tell it to go with the highest version or with the highest minor version. You can tell it to load to different versions. It's really up to you. It's quite flexible here. Okay, so at the end of the day, I'm defining which libraries to share. This was my Microfrontend. Traditional Angular application plus this configuration file. Now, let's move over to my shell. Also, the shell is a traditional Angular application, nothing special in here, nothing special, but a Webpack config that looks the same. And also, this is just a partial one. Here I can get rid of the first section because now I want to configure my shell. Here I can map a path. I'm saying, hey, the path MFE1 points over there to the Microfrontend 1. By the way, over there, it's also called Microfrontend 1. And this is the metadata file, the remote entry point. The shell needs to load upfront in order to be capable of communicating with this Microfrontend. As you can see here, this is quite hard-coded, isn't it? Here, this metadata file, even the name of the Microfrontend is hard-coded here. This is what I'm calling static federation. And this is quite nice for testing and debugging. However, very likely for production, you need an alternative, which is what I'm calling dynamic federation. Dynamic federation means that we don't need to configure anything upfront. Everything is defined at compile time, at runtime. That means at runtime, the shell can query a REST endpoint to find out which microfrontends are available. And then it can tell at runtime Webpack, well, now I want to load this or that. But for the time being, let me stick with static federation because it's a bit easier for the sake of demonstration. Also here, I can share stuff. I can share my NPM packages. It's basically the same section as we had before. This is my shell. A simple Angular application plus this configuration file. Now, of course, we need to have a lazy route using this path here to load something from the microfrontend over there. And for this, I'm switching to my root configuration, my app routes file. In here, I have already prepared my lazy route. It's nothing special here. It's a traditional lazy route from Angular's perspective. We have a path, we have load children, we have a dynamic import. And the dynamic import is using the map names mfe1/module, which is pointing over there. The thing is, as mentioned before, Angular does not even know that we are loading a microfrontend. For Angular, this is just traditional lazy loading. That means for Angular, this is fine. It's also fine for Webpack because it knows the mapped paths. It's not fine for TypeScript. TypeScript is saying here, TypeScript is saying, hey, I don't know this very file, so I cannot check the types. And of course, TypeScript cannot know this file because it does not exist. It is just a virtual one. And that's why we need to ease the TypeScript compiler a bit. We need to tell the TypeScript compiler, hey, come on, trust us, I'm an expert. This will work at runtime. Don't worry about it. And for this, we need a DTS file. The name doesn't matter at all. As long as it ends with DTS, it will be picked up by the TypeScript compiler. In here, we can define that we have this module. The TypeScript doesn't know it, but that it will work at runtime. And with this declaration, the TypeScript compiler is fine too. And that's it. So basically, we just configured a module federation on both sides. We've introduced a lazy route, and that's it. So let's try this out. For this, let me jump into my console. Let me start my shell. And here, let me start MFE1. I don't need to mention the board anymore because the plugin has already registered a custom board. Of course, this takes some time, you know, Angular and the CLI. Everything is compiled and bundled. And by the way, you will see some warnings because the Webpack 5 integration is still experimental. But don't worry about it. Those warnings are in red letters, but don't worry about it. It is really just a warning. Okay, MFE1 is started and so is the shell. Let's jump into the shell, let's reload it, and let's click here and hey, it's loaded at runtime. I've loaded something from a different origin into the middle of my application. How cool is that? So let us also have a look at the network tab to find out what happens at runtime. So let's say I'm clicking here. Then we see that at runtime, on demand, this file is lazy loaded. And this file comes from over there. You see it here, localhost 3000, while here we are going with localhost 5000. And one more time, going with different origins and ports is not a prerequisite, but it proves that I'm loading something that was separately compiled. Also, if we look here, it's pretty tiny. It only has 11.6 keys, which clearly proves that I'm sharing Angular. If I needed to reload Angular, this would be far bigger. But as I'm sharing Angular, Angular just needs to be loaded once, in this case alongside the shell, and the shell shares it with this Microfrontend. And as mentioned before, you can even go dynamic. There are some runtime APIs to load all this stuff at runtime. Perfectly. So perhaps you're saying, no, well, this is solving that much issues for me. I really want to have this. When can I use it? Well, the thing is, Webpack 5 and so module federation is currently final. You can use it immediately for production. However, the CLI 11 is currently only providing an experimental opt-in for Webpack 5. This is the issue. That means we need to wait for CLI 12, which hopefully comes with an official Webpack 5 integration. Until then, you can go with the experimental opt-in, but this is more for prototyping and for experiments. Saying this, I think I have already mentioned it, CLI 12 is due in May, so it's not that long, in May 2021. So it's not that long. You can start now with prototyping and then switch to production. Great. If you like this presentation, you will very likely also like my free ebook. You can find it here and you can download it here under the URL angoraarchitects.io/book. I've updated it currently. It consists of 5 chapters dealing with module federation and even other chapters dealing with other stuff in the area of enterprise Angular. Okay, let me come to a conclusion. What did we see today? We've seen that module federation is really somehow a missing link because it allows you to load separately compiled and deployed source code. And this is the key for microfrontends. By the way, not only for microfrontends, but also for, let's say, plugin-based systems. Plugin-based systems where you load some strategy, some implementation at runtime into your application. And we have also seen it perfectly works together with Angular. In this case, I'm calling it federated Angular. Saying this, there is one last thing I really want you to remember, namely, this is now the chance to become the next Leonardo da Vinci. So take your chance, try out module federation and build something that was not buildable before because we didn't have the right material. Great, so thanks for having me. Here you have my contact data. I've already uploaded my material to my blog. And if you like, follow me on Twitter so that we can stay in contact. Thanks for having me.
Thank you very much for your presentation today. That was super interesting and very well done. And thank you very much for your time. So we have some questions that are starting to come in. While we're answering these, if anybody does have any questions, you can visit slido.com and use the hashtag WeAreDevsLive in order to ask the questions. So the first one that's come in is, this is from Sergio. Can we mix stacks and still use microfrontends?
Yeah, that's possible. I mean, it's not that straightforward because React has not been defined to be loaded together with Angular into the same browser. But it's doable. You can combine web components with module federation. In this case, web components abstract the framework away And module federation allows you to share dependencies. Perhaps you have 3 microfrontends that want to share Angular 11, and 3 more microfrontends want to share Angular 12, and 3 more microfrontends want to share React 17. This can be accomplished with module federation. So it's about the combination of both module federation and web components. And I have published a blog article about this, also about the pitfalls that come into play when doing this. You can look it up on my blog.
The next question is, will this video be available to watch later? I believe it will be on the WeAreDevelopers website. So yeah, I'll try to get a link to that and further details while you're answering the next questions. Okay, so the next one is from Lily. How do we make sure that devs use the same standards and rules when working on different parts of the micro front ends?
Standards and rules. Yeah, I think that's the big point of micro frontends, because it's about defining autonomous teams. That means each and every team can do what they want. Of course, normally we are self-limiting ourselves. Perhaps we want to agree upon a common major version of Angular. Perhaps we want to agree upon some kind of design system, some kind of shared component library. But at the end of the day, the teams can work in an autonomous way. This is what micro frontends are about. And this brings back the agility, because now instead of having a huge team, you have several tiny teams that can work like a little startup on their part of the big overall architecture.
Sounds great, thanks. Going back to the earlier question, I just wanted to follow up about it being recorded. I got the details that people can register on WeAreDevelopers.com, and they can join and see all of the videos and sessions that were presented today at any time on demand. All right, the next question is, what if people use different libraries like Lodash, Ramda, or similar?
Yeah, so it's not that a big deal. Of course, it is increasing the bundle size. That means you have to evaluate if this is an issue for you or not. And if it is an issue, you need to self-limitate yourself. You need to limitate yourself, meaning you need to agree on a set of libraries. But from a technical perspective, if you leave all the performance considerations away, it's doable to mix and match different libraries.
Thanks for answering that. The next one that came in is, what if people, what is the best practice to implement versioning with MFS?
Yeah, so there is a smart default provided by Module Federation. Namely, by default, it is loading the highest compatible version. The highest compatible version. It's quite a term, isn't it? It means that if you have, let's say, Angular 11 on this side and 11.1 on that side, it decides to go with 11.1 because 11.1 is, according to semantic versioning, backwards compatible to 11. This is the default behavior. But you can configure different behaviors. You can say, hey, if there are different versions, load both of them. Or you can say, just emit a runtime exception if there is more than one major version of this or that library. It's really flexible when it comes to this.
Thank you. Maybe a related question is, how do we use component libraries that we created, all the MFES?
Yeah, so you would use it the same way I've used Angular itself. You would load it into your application and define it as a shared library. Of course, it has a version number, and that's why Module Federation can find out if the version used by this micro frontend is compatible with the version used by that micro frontend. And if this is the case, then it's only loaded once.
Thank you. Another question I received is, how much faster is the dynamic federation in terms of loading speed in your experience?
There is not really a difference in terms of loading speed. It is just the time about the time where you define which microfrontends are available. But performance-wise, it's the same, I guess.
And Oleg asked us a question saying, is it advisable to use microfrontends with large teams? Wouldn't it be too complex to maintain?
Yeah, so honestly, it is really intended for huge teams. I would say if you only have one little team or just one team, then don't use it, because very likely it's an overhead for you. The thing is, if you are loading something only at runtime, you are converting compile time dependencies to runtime dependencies. That means you are not capable of finding bugs or issues at compile time. That means you are losing a lot of comfort. So this is more for huge teams. This is really intended for huge teams that want to scale, that shall be subdivided into a lot of smaller teams that want to work in isolation.
Great, thank you. There's a follow-up question from Lily asking, if everyone can work with their own taste and their own standards, and then they end up leaving the team, you could end up having a situation where you have code that nobody understands. Isn't that a risk?
Yeah, I guess so. The thing is, it is possible at the technical level, but as mentioned before, you will very likely limit yourself because you don't want to have a framework zoo and you don't want to have an architectural zoo. Normally you define some overreaching standards. But at the end of the day, you are moving the decision from a central point down to the leaves of your hierarchy tree. And that means you can do fast decisions that are now important for your very domain. So it is more or less what agile methods are telling us.
Thank you so much. That concludes our questions. We had multiple comments that said that your talk was very interesting and that it was well done. So thank you very much for your time today. We really appreciate it. And have a great rest of your day.
Thanks for having me.
Thank you. Yeah, and then just to let everyone know, the next talk is going to be starting in about 18 minutes. So we'll look forward to seeing you soon. Thank you.
dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Go hybrid. As a coach, my offense is nowhere without a solid line and agile, skilled players. I need the speed of a running back and the security of a lineman. A hybrid cloud approach with IBM gets your business both, so you can manage data and apps whatever plays come your way.
Here, coach.
When security meets agility, you're unstoppable. Bring it in, guys, bring it in, bring it in. 1, 2, 3, hybrid!
Welcome back, everyone. I am here with Serg. Serg is the Director of Software Engineering at Guidewire in Dublin. Serg, thanks for joining us. How are you today?
Thanks for having me, guys.
Good. And do you want to tell us up front briefly what will we learn from you?
Sure, yeah, guys. Today I'm gonna speak about micro apps. So it's how you use micro frontends and how you also connect them structurally, how you organize the teams, deployments, how you organize micro frontends between the teams, what are caveats, and which specific knowledge you need to have regarding security and other pieces. All this based on the delivery with my teams of a few products and frameworks we're using in the company and our customers. So yeah, that's the part I want to share with you guys today.
Okay, very cool. Serg, the stage is yours.
Perfect. Okay, you like. Perfect. Okay, so let me start, guys. Today I'm gonna talk about front-end micro apps and about myself. So I'm director of engineering at Guidewire, and I'm a head of development of Utron. It's a design system and front-end framework delivered by Guidewire, used internally and by customers. There is also a huge amount of applications and based on digital products of the company, where we're using both front-end and back-end, and all this delivered in the cloud, and some aspects of this I will touch today. I'm also active in the community, contributing to ECMAScript and also cloud technologies, and I'm sharing all this in my blog and, of course, contributing to GitHub and other aspects. So, yeah, that's shortly about myself. And today we're gonna speak about micro apps in this path. So I will describe why, reasoning, and challenges we have as developers and engineering leaders. Which brought us to the micro applications. How we're gonna do this? I will touch the Webpack module federation and do the demos, of course, and we will discuss caveats and proper and different takeaways based on the experience. Right. So we set the stage, and now let's discuss the most important question of ever: why? So we will start from overview of evolution of a typical product. So I will take an example of Spotify, which actually leverages micro apps approach. So imagine one day it started as just an idea. I want to be able to listen to music. So all my users and customers want to be able to do this. Perfect. So you creating something like this widget, yeah, in your product. You need just a few developers who just were putting together a UI, connecting this with some particular stream, and if you need to onboard another developer or add some particular feature or your UX edition, perfect. It's very fast. You're onboarding very fast, delivering quite quickly. Okay, then typically it comes to the second stage. So users like the idea and they PM asking a bit more. I want to show info about the disk, I want some additional information, how many followers it has. So accidentally, you need a team. So developers onboarding and deliver still fast, but it's already a team. You need to start building a proper process for this particular part. Okay, next. After you start, working that, I need a control. It's another request from your customers and PM. controls with volume, with next track, previous track. Okay, you see, it starts being more complex. We need a team or two. Developers onboarding and delivery still relatively fast, but slower, that because it becomes to be a bit more complex. Then typically it starts being more interesting. So you know what, we have multiple users. For different users we need different type of subscription. We need search through the library, subscription. Immediately you need 2-3 teams. Why? You need some authentications microservice, you need immediately some groups and access rights, you need search, maybe Kafka, maybe something else. Surprise, surprise, it's a lot of interesting dependencies. And onboarding starts being slower. And delivery still relatively fast, but you need to know all the aspects of the system. And then next step, typically one of the executives says, you know what, we have good relations with iTunes maybe, and we want to add radio integration, and step by step you come into the need of 3-4 teams. Developers onboarding is much more slower because they need to learn all these aspects which were taken by different teams, by different agreements, deployments, and you need to start building SDLC, software delivery lifecycle, right? So developers onboarding is much slower if you keep in all this in one code base, and it all depends on each other. So features relatively delivered slower, but still okay. Yeah. So when you come to the next stage, typically it's asked like, okay, now we have successful product, we need social integrations, we need advertisement, you see this particular aspect of your application. What it means that slowly but surely you need a department. It's quite a few teams, developers onboarding very slowly if it's all kept in one particular part. Delivery of new features are slow, PMs are not happy, just like sales doesn't go so fast because they cannot sell the features. And you, as a developer, you need to learn all the aspects. If you're doing some changes in the advertisement, it can be dependent somehow on social integration or somehow on your authentication and other aspects. It becomes complex and complex and complex solution added on top of each other. Okay, so what I'm saying, if we discuss the example of the application as below, we will have some team structure to deliver this. Most of all, you will have platform team, which will contain the core of the framework. For maybe it will be 2 platform teams, one for UI, one for backend. There will be some microservices team, authentication team. There will be social integration team, and all will be a bit of chaotic if you just like trying to put all this together with without some control. Then your engineering leaders, your PMs will be a bit confused how to split the work. So industry slowly but surely came to the understanding that all this should be divided and properly structured. So there is Conway's law. It says software follows the organizational structure of people who design it. It's very important because slowly but surely software follows the real requirements of what we need to deliver, what market needs, what users need in the end. So remember many years ago, decades ago, it was one big monolith. Yeah, so we use it. It was different languages. PHP, Java servlets included with Java, GSP, other aspects, all big, huge monoliths you couldn't actually even divide parts of. Then, again, around a decade ago, we started splitting towards frontend and backend. So there was frontend developers, they know CSS, JavaScript, aspects of interaction with UX, and there is backend developers who more integrating with the services, databases, and other aspects. Yeah. Then it started being the era of the cloud. So with Google and Amazon Web Services, we started speaking about microservices. Microservices started being more relatively popular and useful across different companies. Yeah, so authentication of microservices, as I said, it could be database, data lakes, and other microservices which are related to delivery of different aspects. Typically, it's for API, correct? But frontend still, in most cases, is a monolith. Somehow, for so different reasons, you need to learn most of the aspects of agreements and solutions used by other teams. So it's all still big monoliths. So slowly but surely we came to the understanding that except just components on front end, we need something bigger, some new entity which is called, let's say, Microfrontend, yeah, which will allow you to structure the delivery according to the boxes I showed you in the example on Spotify. Spotify actually started from iframes for this particular parts of their application. Okay, so question how? Yeah, how we can do all this Microfrontends. Here, I will say you already for many years, there is many different frameworks which allow you to create Microfrontends. It starts from single SPI, which is quite popular, and there is many more. So it's more than 5, it's more than a dozen of them. So they sort in very specific needs. So some of them enabling works very perfectly with Vue. Some of them working very perfectly for the solution when deployment depend on only one API. So they resolve specific tasks effectively, which is good. And there is years of experience. What cons I have that they are not so much universal. They're not so popular as I would like to have. So just like when you have a developer, and if you go to the team and ask, do you know, for example, how to use, I don't know, Luigi? If you have one guy in whole department who would say yes, it would be good. So there is no, you need to train people and other aspects. So question how I would answer by asking a question. There was a poll which was sent by the guys to you at the very beginning of the presentation, which build tool you are using. So let me take a look what results you have at the moment. Here's the poll, 25 people voted, and we have Webpack as a champion here. It's predictable. It's very predictable because here is a survey of 2020 of developer survey state of JS. It showed up absolutely the same. Webpack is dominant at the market, and people know how to use it. It's popular. It has brilliant adoption, and it's moving forward. It's evolving. Perfect. So knowing this particular part, I'm saying we need something what you guys know, what you used, and guys in Webpack, there was a working group who started getting the feedback from the community. I also was contributing to this feedback and honestly described that except team organization, we need something simple which would allow you to bring the application into this logical blocks and enable interaction between them. That was the motivation. This slide from one of the creators of Module Federation, contributors to Module Federation in Webpack 5. And the main idea, again, to enable mid to large scale application, enable separate application parts, and allow them still work together relatively coupled. So here is a simple explanation how it works, but in the next slides, I will go in more details. So in my demo, which I will show you in a few moments, I will say there is a micro application. In my case, it will be gallery, yeah, which using Module Federation from Webpack, which you mostly heard from previous presentation or before. So gallery application will be exposing some of the components, and this component will be called image gallery. It could expose whole application or just specific parts. So it can expose either whole the micro app, all, or it can expose micro components, micro parts of it. Okay, then there is a shell application. Shell application is a parent which can locally work with your local host or just can be connected directly to the URL where you publishing your application. It can be internal staging or external URL. So you see this part, it's much more runtime based. So there is magic from Webpack, which is build time, and there is magic from Webpack, which is runtime. This is more runtime URL dependent. In this particular app, you're doing nothing else than saying, you know what, from my micro app, I will be using some part of it. Okay, so why I was saying that it's scalable. If you ever use ECMAScript modules, in most cases, you use a dynamic import. Anyway, as only speaking about lazy loadings these days, you're using dynamic import. It's native JavaScript functionality, which allows you to say, okay, load some ECMAScript module dynamically from this particular URL. This is native. So in my particular example, I'm using React. It could be Angular, it can be Vue, whatever. Everything what is native is scalable. That's why I was saying that framework agnostic allows you to use any particular solutions on top of your micro app. So demo. In my demo, I will show you. So recently it was St. Patrick. I will show you the gallery. And let's say gallery is a micro application which provides, except the user experience, how it's shown, it also can take as input some configuration of images to be shown. It also can work with some particular API, and surely it should work locally and easily be deployable to some particular S3, for example, bucket. Okay, let's go to the demo. Okay, this is my micro app. My micro app, as I said, exposes itself with module federation as gallery app and exposes this particular gallery. Let's take a look. I started it locally, nothing special. Here is like localhost 3002. And after that, in my shell application, I'm saying nothing else except, okay, take a look. I want to reuse this gallery application and making sure that I'm using this remote entry JS, which exposes this magic from Webpack. I believe you already know this particular part. Okay, and then as only I need to actually use it in my shell application, I'm importing it using my dynamic import and using it, image gallery. So let's take a look. Here is my shell application, and everything what you see in the red border is actually a micro app imported from another host, which is localhost 3002. To show you that I'm bullshitting you, I will just in my image gallery add some text. So you don't believe it's real, so demo, to be absolutely sure that I'm not bullshitting you. We look in here, what we see, demo, you still don't believe it's real. And what I see here, I'm just like updating my shell app, exactly the same. So it's truth. It's this magic work from one app to another app. Yeah, so nothing unexpected here. It gives you the tool. This tool allows you to also share some parts, which we'll discuss later, like, React and other pieces. And also quite easily, you can deploy this micro app. You see the URL. The URL actually published it to my blog and Hospodarets.com, and nothing special. It's the application. So you can work with it separately. You see it has header and other aspects, and the same particular part of application and whole application can be included here. So you see it's different URL. When you load it, Smart Webpack will just like enable this particular magic and go to this remote entry either from different domain or from different URL and just take everything, including images, including script from there. So that's how it works. So you have the instrument. Okay, so if I have the instrument, what the hell I can do with it? I want to discuss with you something very important. Why the hell I'm saying micro app, not just Microfrontend? So I will even stop sharing just like to discuss this with you seriously. Okay, microservices. Microservices is an approach, it's an architecture, which is a strategy of breaking application into services that are lightweight and loosely coupled. We know this aspect because it's years of microservice development. Microfrontend is absolutely the same approach, but for frontend. Yeah, and we have a tool to enable it. We just discussed it. Micro app. What is micro app? Micro app is a thing which leverages from both approaches, microservices and microfrontends, and is an app which is highly focused on performing just one task, but doing it very well. So it's all about separation of concerns. And simple example of such application can be the authentication, which I already mentioned. Sign in, sign up, forgot password. All this can be organized in a tiny particular microfrontend, which speaks with authentication microservice and provide you the ability to log in different applications across your organization or even outside of your organization. So that's what is called micro app. Okay, I will continue. You need to make sure to remember, similar as I'm doing, you need to hide header, you need to hide all the surroundings to make sure that you changing just the content and reusing this particular part. Why the hell you need header in the micro app? Because sometimes you need, it's a full application. You need whole the developer experience, like to log in, whole the developer experience to change the pages of the application and other parts. So make sure that you cover in this particular case. Something what is very interesting use case for design systems. So for example, Utro as front-end framework has a number of UI components. Typically, most of organizations have these design systems. UI components used across whole the number of teams, yeah, buttons, accordions, and other pieces. What if I tell you, yeah, any such component, button, accordion, anything can be a micro frontend? It's a micro component essentially. What does it mean? Storybook recently published the new version with support of Webpack 5 module federation. You can use all your buttons, not from npm artifactory or something else. You can use it from URL, and as only you publish in the new version with the fix immediately applied everywhere. There is, of course, a caveat with this. Don't use it now because there will be network problem. You will start bombing one particular service, and whatever you apply there, just like even if it's the best implementation of S3 with CloudFront, it will go down if it's overloaded. So be careful. Whole the community does start, exercising this approach, but I'm saying technically now it's possible. Then, okay, what about the sharing part? Remember I showed you that it can share different parts. Okay, so if I can share React and Angular, what does it mean? So first of all, it means that performance performance is amazing. Yeah. So performance of your app is much more faster because you don't need to load it twice when you're using, for example, iframes or other aspects. But there is much more than just like inheriting of React, because if this micro app is nothing else as a component, you can from shell app control its authentication, localization, theming, and pass it down. Yeah, so all this particular aspect can be passed down in the embedded app. So it's not just sharing the React and Angular and other aspects, but also consistency of other aspects of the application. So finally, you have something to enable all the pieces together, because micro app is nothing else as a component. It can be React component, Vue component, or other aspect. Depends how you organize your development. And now let's discuss other aspects. It's also about team organization. As engineering leader, as director, I know what it means to organize a few teams. You need to be very carefully pick what actually team knowledge is, and just like to enable them with the proper, not just structure, but also with technology, with what they want to achieve, and of course enable their career. So what I'm saying, micro frontends and micro apps is also about team organization. Each team can have separate Git repository. They can have separate deployments, and they can have separate even technology. But here I'm saying that yes, you can do it, but it should be relative freedom. It should be still set of standards. We'll come to this particular discussion, but it all simplifies the onboarding. You don't need to learn how all the infrastructure of your company works, how, in different teams, how they organize its search, for example, and how it might be impacted by your change of Dash version, yeah, which is a bit too much. But what I'm also saying, and we did this a few times, it enables you to actually migrate your application. So instead of big bang, you have the application similar to Facebook, and you need to migrate from Angular to React, or from AngularJS to Angular. Yeah, just like you can do this either in one big bang or step by step. When you find the logical pieces, define them as micro applications and start changing them step by step. Because after that, using Webpack Magic, you can still include all of them into one big shell app. A lot of control needed for this, so only if you're organizationally and mentally ready and there is a requirements, do it. So I'm saying again, technically it's possible. Okay, something what I liked a lot. So as only you start having micro apps, especially some framework which is except Webpack taking care about other aspects. Remember I told you theming, localization, other parts. Imagine you have 7 different applications in your organization. You immediately, as only you start using micro apps, having this portfolio app. So Spotify is not exactly portfolios app, but something what comes what takes this together. but portfolio of the applications of your company or your department can be done like this, because now you just everything what you're doing, you just put in a shell application which exercises and leverages micro apps inside. That's it. It's quite easy. There should be, for this particular case, additional coordination of shared libraries and dependencies, right? So all this versioning can be properly managed. So what is the best practices for this part? In the development, if there is 1-2 sprints till actually everyone specifies on the specific version given by the platform team which is responsible for this. After that, when it's all aligned, it goes to actually next environment. So for example, it's staging or pre-prod or other. So this is simple representation because I'm cautious about the time. So yeah, we can discuss this more in questions. What about another use case? Yeah, so imagine you have huge, just terribly huge amount of pages in some application. Yeah, so AWS console. If you ever use it AWS console, you know that it's more than 200-300 pages there. If you ever use it Facebook, you know that there is parts of Messenger, there is part of actually responsible for groups and part responsible for other aspects. So as only you start having huge UIs, you need to start gradually spread this across the teams and provide common dependencies and shared aspects. So how it works? Typically, there is a need and department of teams coming together and agreeing. There is somebody responsible who defines, is it React, is it Angular, or other particular framework used across, what is the set of shared libraries, what are the versions per let's say a quarter per sprint delivery, and then you start spreading this per team. So one team starts responsible for one aspect, another team for other aspect. Okay, so that was about the use cases. And based on the experience, what caveats you have when you delivering micro applications? It's also based on the experience of building micro apps by ourselves and from the feedback in the community, especially what Webpack should have to care about. Versioning deployments. I already spoke about this. So once again, there should be one platform team which defines at least what is the platform is. It's typically guild. It's architect guild which define and share for whole the company, or at least like department which using this approach. What's the reasoning behind them choosing some particular platform? And of course, it goes with the approval from engineering leaders, directors, VP, and blah, blah, blah. Yeah. And after that, there is responsible team which define which particular version. So typically, it goes together with the team which developing front-end framework for the company, which typically works on design system or working together. So it might be examples might be I don't know, Salesforce Lightning. Yeah, so something that defines the subject across whole the company. And after that, the consistency must be shared. So in Webpack, you can, for example, configure. Yeah, I allow a bit of freedom in the under one major version, so it's current. Yeah, and or otherwise, I'm requiring the exact version of React. So my suggestion, based on the experience, require totally one version of the main dependency. If it's Angular, if it's React or something, don't. So we tried this many times, about 5 times. Every time we failed. Yeah. So try to have one exact version of the main dependency and framework. You can have some freedom on something like Lodash and other pieces, but main dependency, no, it should be just like very aligned. Another aspect, which is very typical, is only try module federation, you will find something interesting. Why the hell it doesn't load? So you will see during the Webpack build the actually error like cannot load, cannot import the module blah. And typically it's because of course, yeah. So cross region requests are by default prohibited by browser. So if you're trying to load ads.facebook from facebook.com, it's different domains, so it will block you. You need to allow use cross-origin requests. So make sure that you're doing this in your AWS and Jinx or Apache server so that it works for regions you want to allow for your micro apps. Then it's interesting. So if you fail on security, your users will very, very quickly just like tell whole the world about this. So be very conscious about security and authentication. Using micro apps, make sure that the most important, very, very most important part, use as micro apps only the parts which you deliver. Never ever third-party dependencies can be using micro apps. When using micro app, you have from the micro app access to full DOM of the shell application. Never allow this by third-party scripts. First of all, they can have errors, which we'll discuss, but they can do some malicious type of activities. Please don't do it. This is also from experience. Use iframes for this and just like send the post message and organize the same particular part of coordination that, something what you're sending for your micro app, not authentication, but some aspects of teaming and other data. Use iframes and post message for these aspects. And second part, limit very carefully what is shared between the shell app and micro app. Make sure that you allow you sharing maybe just very limited amount of things, localization, some data maximum, maybe some authentication token minimum amount of this. Don't allow for micro app to know anything about shell app. Otherwise, micro apps will start speaking with micro apps. You will have very strange architectural solution, and it will be just unfixable. So make sure that you have the separation. Okay. Error boundaries. This is easy, yeah. In Angular, in React, in JavaScript, and Zend, yeah. Errors actually bubbling up, yeah. So if you have error in some piece of application, all your app can go down. But as only you have the micro apps, it means that every part of your application might be controlled by somebody else. Accidentally, they might publish the version which contains a bug. Then whole your shell app, including all other micro apps, will go down. Don't do it. Make sure that you have error boundary applied to the micro app global level. This is easy and typical approach when you're using micro applications. Need some magic water. Okay. Here, single tool providers. What I'm speaking about. Typically, when you have your applications, each application in most cases has models, have some inline notification, something global. Typically, you have global provider, which allows you to set the notification, something happened on the server, or task is done, or something else, or show the model. So when you using micro app separately, all good, no problems. But when you're using micro app inside of shell app, it starts being funny. So micro app saying show the notification, and both provider of micro app showing the notification and shell app showing the notification. So you'll have two notifications, and it starts. Yeah. So make sure that when you organize this messaging system between your micro applications and shell, you also reusing the providers from the shell application. So speak to the shell application and say, okay, send the notification, show the model. All this should be limited by the amount of things which you allow communication. So communication should be allowed from shell app to micro app, and from micro app to shell app, and very limited. Never allow micro app to a micro app, except, I don't know, for some reason you needed this. So this is out of control, to be honest, based on the experience. And on the right side, you see the famous image 2-3 years ago, when micro apps concept, Microfrontend concept came into the community. Community just like was not ready, but just new for this term. Yeah. So many people, including creator of, sorry, not creator, but Dan Abramov and many other people couldn't easily understand why so big hype and discussions about microfrontends. So not everything is a microfrontend. Absolutely not everything. So typical rule: if there is something transactional, it might be a candidate. If there is a requirement from your PM or your sales or your organizational needs to deliver some piece of functionality separately and at big different cadence, only then consider micro apps. Otherwise, always consider a component. It's faster and easier, just like when it's just a component. You don't need a separate repository, you don't need a separate specific solution. So be conscious. Of course, discover your architecture and your organizational needs. So that's it. Be conscious when you use micro frontend, and if you're using this right, you'll benefit from this a lot. Okay, so takeaways from my presentation today. Creating micro frontends in 2021 is easier than ever. You have Webpack 5. It takes care about creating, sharing micro application, usage of micro application and shell apps, and also sharing some dependencies. Perfect, it's done for you. Of course, you need to configure this, but you have the tool. Tool is perfect. Tool works. Tool actually across most of the projects. Secondly, make sure that you organizationally fit into the micro app. If you're trying to actually deliver two micro apps between the teams who has no idea about each other and try sharing with the shell app something sort, it will be nothing else than competing problems and delivery fails. Yes, so make sure that organizationally it's logical fit how you need to deliver your parts, and coordination is a strong requirement. For example, in our organization, we decided that Utro as a front-end framework will define main dependencies. For example, it's React, it's Lodash version blah, it's React Router version X, and setting like Node.js and other aspects. All this, when it's set by one team, of course, this team should interact with whole organization and gather the feedback from customers, from others. So make sure you have something this, guilds and other aspects. And always continue to learn something new. 2 years ago, I couldn't even understand why the hell I would ever need micro. Today, I'm using this in many projects and solutions. So continue learning and finding the path how technology can enable your delivery, your teams, and your organization, and your own career and knowledge. It's always interesting to learn something. That's, I would say, it from my side for today. You can find the slides online and check other aspects, and feel free to follow. Thank you very much, guys.
Okay, Serg, thank you very much for the talk. I'm just checking if we have already some questions coming in. I saw some already. And okay, now it switched to the poll. So let me just check. So, okay. I think some questions came in while you were talking, so it could be that we already have something answered, but it's maybe a good way to repeat. So could you say a general rule of thumb on monoliths versus microfrontends?
There is an intermediate step, guys, between monoliths. There is, of course, split to frontend and backend, but I believe you speak in monoliths of frontend and microfrontends. Of course, the rule of thumb is, in general, if I will start, just like without very long answering, if a developer, usual developer, just like normal, middle developer cannot learn all the aspect of code base in, let's say, 2 months, you have a problem. You can consider this. If then a PM will say, if I cannot deliver simple feature like I don't know, additional aspect of authentication, maybe switch authentication in, let's say, reasonable time frame, like again this 2 months, you have a problem. Then if from other aspects, I would describe if you see that there is pandemonium of changing even one rule in your team cannot innovate. For example, simple example, enzyme started to die slowly but surely. Just like so React testing library started being more and more popular. If to roll out this, you need to spend months and months and do this in one big bang across whole your solution, if you cannot do this in, let's say, again, this 2 months, magic 2 months, then consider microfrontends. Then you can define some particular parts where you innovate, and some parts where you just like follow the standard delivery till actually innovation becomes more stable and you gather from them. So I would say that's a funny rule based on the experience. It's just like this, like, you know, less than 2 months is not enough, more than 2 months is too long. So that's it.
Okay, thank you very much. Then the next question from Benk. How do you monitor freedom? You sure have some rules for everyone. We had a similar question in the last talk. I think it was Lily, and she also was touching a point here, because she said, like, if you give everyone too much kind of freedom and everyone can kind of make its own rules, then it could be chaotic. So this is, I think, in the same direction. What's your take on that?
It's natural. When you define a platform team, they need some time to prove themselves. They need to work with different projects, so they cannot start be a standard for whole organization. You need to start from limited amount of teams who work on this new solution, right? So somebody defines, let's say, 2 micro apps and 1 platform team. Start from growing this, like in this particular part. As only you see this becomes more stable, these 3 teams delivering effectively, maybe for 3-4 actually delivery cycles. It might be, I don't know, weeks or months or quarters in your organization. Only then start spreading this across organization. So I saw in the practice, as only 1 team come in and you give them the power to say, we go this way, it will start be very, very problematic, because we all have opinions. Put together 3 architects and you will have the fight till the evening, actually for 3 months. So be careful with this particular part. You need consciously work with requirements, PMs, and also with architects. And start from smaller piece, and only if they proved it, move on. We started with the same as usual, just like, so we proved this on very small piece of organization. So imagine 3 years ago, I'll be honest, just like, we had a situation when we had around 50 different solutions and tech stacks in the company. And the try was to create 50 first and to slowly but surely come to 1 solution and platform team, which defines at least this basic, like, is it React, is it Angular, is it something else? It took years, I'll be honest. So it took 3 years till we just like came to this particular scale. So slowly but surely roll this between the teams, and then just like have the guild and have the architecture meetings, have the Slack channels where you supporting your customers internally and externally. So that's my actually suggestion for you. It requires, of course, strong engineering leaders and architects on the place. So, somebody who know not only architectural aspect, but can work with other teams and listen to their feedback, to be honest.
Okay, thanks. There's a related question, basically asking if you need a dedicated person for the coordination and guidance within the team, within the organization.
Typically, yes. I'll be honest, it's like it all comes. So there is team leaders, technical leaders, and others, and typically there is a group. So in most cases, it's a guild or some group which are in touch. Yeah, they together. Of course, they have their own leader. Yeah, just like allows them to define their own leaders. They will find the path. So I'm saying the voter will find the path. Make sure that in every team there is a driver who also is responsible. In many cases, it's technical leader, or there is also, let's say, architect, or even if it's a developer, it's somebody who the team follow. Who saying, what, based on the agreement, we agreed that in 2 sprints we need to coordinate update to this particular version of React. For this, you need to have the channels. You need to have email channels. You have to have the channels of meetings between PMs, where all this also agreed in advance. So all this goes into your schedule, into Jira, and also driven by these technical leaders. Yeah. So this technical leader has 2 tasks. Yeah. Of course, coordinate with their own team, but also contribute team requirements and team needs into the guild. So it's representative whose voice should be heard across the organization.
Okay, thank you very much. Then the next question is from Keita, and she or he is asking if you have a preferred Microfrontend library.
Yeah, it's Webpack 5. Essentially, before I use it about 10 of them. The most, if you wish, it's before Webpack 5. I was using the most single SPA, because I needed just like to connect an Angular with my team. I needed to connect AngularJS React at the time, and single SPA helped. When we needed to connect multiple frontends and Webpack 5 still was not there, it was single SPA. Then, when we migrated to React, we decided to use actually Microfrontends as well for some aspects of our needs, and Webpack 5 still was not ready. So we, knowing that Webpack is coming, emulated similar functionality using Webpack 4. So we just emulated similar imports. We ourselves created the micro, let's say, components which can be shared between the applications. So each application became app and micro app at the same time, because we started spreading the same framework across organizations. All teams were using so-called user applications. Many teams were using this, so we enabled the feature which allows you to say, you know what, also make this micro app. This is something what we plan to discuss with customers, and if it fits for them, we will actually deliver for many of them. That's how we spread the microfrontends in our ecosystem.
Okay, thanks for the answer. And then there is a last question for this session, and it is: is this only usable for large-scale apps? Using micro apps in startup projects, would it be a good option?
Depends on the scale, I'll be honest. So from my experience, if you have less than 4 teams, don't do it. Don't do it, just like it doesn't make sense. If you have scale of 5 teams, and for example, at some point you're noticing that one team started using some technology and some of the teams in your startup didn't know about this, then and only then consider actually scaling to micro apps.
Okay, Serg, thank you so much. So this was it for this session. I hope everyone enjoyed it, and we are going in a short break of 13 minutes and coming back with the last session of the event, talking about Svelte. Looking forward to that one. Welcome back, dear developers. We are going into our last session of the event and of today, obviously. Markus will tell us something about Svelte. He will give us an introduction and a theoretical part, and will also show some code examples. So very much looking forward to that. So Markus, the stage is yours.
Welcome everyone to my talk about why I recommend Svelte to every new web developer. This is the agenda that I prepared for today. At first, I will give a small personal introduction so that you know the background that I'm coming from. I will continue with explaining basically what is Svelte, so also for newbies that they know what's up. I will continue with a timeline of Svelte and like a little bit of a history about why the framework was created. I will also explain to you how I discovered Svelte and why I'm using it. Then there will be the coding part, and I will showcase some examples to you. Then I will not only want to show you the pros, but also the considerations and the cons that you have to know if you decide using Svelte. Afterwards, I will explain what my recommended tech stack currently is for when you decide to use Svelte. I will list some big name companies that are currently using Svelte in production. And last but not least, I will talk about the future of Svelte that I see and also give you a conclusion. So I'm currently working as a freelance full stack web developer. I have about 5 years of coding experience. I'm interested in topics like performance, modern tooling, code quality, and accessibility. Whenever I find time, I will also do some open source contributions. And in the past, I wrote code for libraries from Microsoft, React Boilerplate, Ethereum, or Svelte. Technical writing is another passion of mine, and I published some articles that were also released in publications like Free Code Camp, HackerNoon, or Medium. And so that you know the front-end technologies that I tried before. So I worked with jQuery before, then I continued with MeteorJS. I worked with React already back in 2016. Then I transitioned to Angular. I had some short projects that I did with React Native and Vue. And now finally, I'm working mainly with Gatsby and Svelte. So what even is Svelte? It's actually a front-end framework. So it's really just a front-end layer, same like React is only a front-end layer or Vue. And it's specifically easy to learn because you have HTML, CSS, and JavaScript in a single file. And there's not many new concepts to learn. The only real concept that I could think of is reactive declarations with the $tag. Later on, I will show some code examples that you know what I'm talking about. Compared to other frameworks like Angular, Vue, and React, we don't have any virtual DOM, and the main selling point of Svelte is that it gets compiled to frameworkless vanilla JavaScript. This is really practical and a great thing because it's absolutely necessary for a great performance. And since it's using a compiler, we can always be sure that it's also an optimized bundle size. And Svelte is all about writing less code and removing the boilerplate parts of it. And so I will show you an article by Rich Harris, who is the creator of Svelte. And he's talking about reducing the amount of code that you have to write is an explicit goal of Svelte. And here you can already see this is a small Svelte file and a small component. So here up there, we would have the script part where you could write your variables and your custom business logic. And below it, in this case, we have our templating or our HTML. And you can see that we have a calculator example written in only 9 lines of code. One thing that is special about here is that in our input type number, we bind the value and it's implicitly coercing it to a number. So usually we would get a string that we have to convert ourselves, but Svelte in this case is handling this for us. Then Rich Harris goes on to compare his Svelte example to a React component that does the exact same thing. And we can already see up here that there is an import React necessary, and also we need to import the use state hook to be able to even set state. So this is not necessary for Svelte at all. yes, I know with React 17, this is actually now optional, so you don't have to declare this, which is a big step forward. The next part that we see is that we need to export default the component to be able to import it in other components. This is also not necessary with Svelte because it automatically gets exported as a default and you can import it wherever you need it. Then we see we have to use the useState hook, and it's not a nice syntax to write. And we need some functions and some methods that we can use in our onChange handler to even update the number values. And on top of that, we also need to coerce it here to be a number instead of a string. And last but not least, we need to also return the actual HTML template part to be usable. Then Rich Harris also explains the view equivalent. So in this case, we see it's a bit shorter than the React part. We don't need to import anything, but here we need to declare a template tag around the actual template that we're writing. So this could be a sign of boilerplate, and we also have to have a root node where all of our content is inside. One great advantage of Vue is that we have the .number, which also automatically coerces it to our number. But in this case, we have the double curlies instead of single curlies, which makes it again a bit more boilerplatey. And below here, we have our script and we have our declaration of our variables, which is also not the nicest syntax. Like if you have to write this out of your head, you might make a syntax error here or there. Yeah, so Rich Harris goes on to explain how many characters each of the frameworks need, and he's explaining that React is literally 3 times larger, so it's always kind of a framework fight for the creator. And it's a really good article, so I linked it in the presentation and you can also check it out yourself later on. So for me, it's really simple. For me, Svelte is the next evolutionary step in front-end JavaScript frameworks. Like I explained to you before, I kind of worked with all of them and went from one to the next. And this is now, I think, the most optimized framework that has a great developer experience. So this is the timeline. So I already said Rich Harris was the creator of Svelte. He's also the creator of Rollup, which is like an alternative to Webpack. And his initial use case for Svelte was that he's working at New York Times and he's doing the data visualizations there. And he just couldn't find a way to have the existing major front-end frameworks perform efficient enough for his use cases because he's handling a lot of data points. So that was his initial use case for actually creating Svelte, which he did in November 2016. Then about a year later, he released Zapper, which is you could see it as a framework on top of Svelte, which is similar to Next, Nuxt, or Gatsby, for example. In 2018, version 2 was released of Svelte, and then in 2019, version 3 was released, which was quite hyped back then because the syntax started to look significantly different from Vue and the other front-end frameworks. And now in March 2021, which is actually now a couple of days ago, the Svelte Kit public beta was announced. And I will talk about it later on in the code examples of what that means. So how did I even discover Svelte? I used to read a lot of articles, and also on Medium, there is the real world comparison. It's like kind of a survey and a test that is done every year. And if we take a look at that, it looks like that. So every front end or every framework that is out there has its kind of real world example app. And this was kind of the first time that I saw Svelte appearing pretty much in the top ratings. So here it's 3rd place next to AppRun and Elm based on the performance. So this is about Lighthouse performance. Based on the bundle size and also on the library size, we see here Svelte is even ranked as 1st place with only 15 KB. And the first metric was lines of code. So also here we see that Svelte is ranked 3rd place. And that was the first time where I realized, okay, this sounds like an interesting framework. It's doing a lot of great stuff for performance. But back then I was really involved in learning React and Vue, and just already had enough on my plate to handle these frameworks. So I was just dismissing it as just another framework that will die a horrible death. But then a work colleague mentioned it again. And so the topic came up again, and I was having a free weekend. So I thought, why not just take a look at the official Svelte tutorial? And really from the start, you can work through this tutorial in 1 to 2 hours, and I was hooked. And you really can learn all of the concepts that are necessary in this 1 or 2 hours. And you will see how many things you always have to write in a more complex way than necessary. And about the same time, I also decided to set up my own website. And I was evaluating also with for Gatsby, Nuxt, and Next, but in the end, I decided to use Zapper. And in the meantime, I also worked for 3 international clients with a tech stack of Svelte. And after all, my bottom line is it's an incredible developer experience, and I don't regret it at all that I didn't pick one of the more popular solutions. And I'm not the only one with this. So this is actually taken from the State of JavaScript survey, which is appearing every year. So in this case, it's Svelte was able to receive the highest satisfaction rating amongst all people who voted, even ahead of React. With 66%, it also received the highest interest rating ahead of Vue.js. We have a 15% fourth place for usage behind the major frontend frameworks. And we have an 86% awareness that Svelte even exists behind React, Angular, Vue, and Ember. Yeah, but now enough of the theory. Let's see some actual code. So this is an actual project. This is the package JSON of a Svelte kit project that I started. So Svelte kit is kind of like, you could say, create React app. And here you see we only have 3 scripts that are necessary. So this is for running the development server and running the development bundle. With build, we can create an optimized bundle, and with start, we can launch that production bundle. These are all the dependencies that are necessary. It's actually more than are necessary. So I installed Pretty on top of it and ESLint, so this doesn't come out of the box, and that's kind of how I opted into it. Yeah, and I'm going to show you the first component that I wrote. It's called Svelte components are easy to understand. And you can see here again the script block that we already saw before. We're declaring here a row that is developer. And here we're rendering the row developer into the h2 tag. And we have 2 paragraphs. And the style block is styling the h2 and the p tag. And what's important to know is that style tags in Svelte are scoped by default. So this style will never leak to the outside. And if we take a look at this in our actual running application, we have here the Svelte components are easy to understand, route, and yeah, indeed, it's a green heading, and we have 2 paragraphs that are italic. The next example that I prepared for you is about the built-in accessibility and unused CSS checks that Svelte has for you. So we don't need to install any third-party libraries, but here, if I hover over the image source, we can see that the image element should have an alt attribute. Like, this is a very common accessibility issue, and we can fix it just by saying WeAreDevelopers in the alt tag. Another warning that is thrown for us is that screen readers already announced the image element as an image. So this image in here is redundant. We can also write WeAreDev here, just for showcase purposes. The next warning that we receive is that a form label must be associated with the control. So here, the input and the label tag are next to each other, which doesn't do us any good. Oh, so in this case, we would want to put the input inside the label so that they're associated to each other. Yeah, and also autofocus is discouraged from you. You're discouraged from using autofocus on input elements. So Svelte would also prefer us to clean this up. And you can see here it's telling us that we have an unused CSS selector H1. And if we look up here, that's actually true. We don't use any H1 in this file, so we can safely get rid of it and don't risk ruining any of the styles. And also we don't have any CSS selector for main, so we can get rid of that. But an image tag is actually used in here, so it's not throwing us a warning for that. The next concept that I want to show you is about the dollar operator. So it's about the reactivity with label statements. So this is a really simple component here. I'm showing you that I can import a component from another file like that. And we can jump into the counter that I created. So the first thing you can see is that we're using TypeScript here. So this is annotated as a number. And SvelteKit has TypeScript support out of the box. So we're having a count of 0 initially. We're having an increment method that would increment us the count. And here we're seeing the reactive statement that I was talking about with the $sign. So what this means is that we're initializing doubled as a variable here, and doubled is reactive based on the value that is saved into count. So whenever count updates, our doubled value will also update. And to make it even more complicated, I set another quadrupled reactive variable here that is reacting based on doubled, which is reacting based on count. And this might sound complicated at first, but it's a really great concept and it works exceptionally well. So here we have a button with an onClick handler that would trigger our method increment. And below we have two p tags that would display our values that we initialized up there. And on the bottom, we have just a scoped button styling that will not bleed into any other components, luckily. And to showcase you how this would look in action is we have our button here and we have the doubled count and the quadrupled count. So whenever I click, we see that it's incrementing correctly based on the value. The next example that I prepared for you is about shorthand attributes for passing props. So again, you can see here, you can also import components from nested folder structures. That is no problem. If I go into the parent component that is here, you see that the parent itself is importing the child and we're declaring a message, hello from the parent component. And this is now what's called a shorthand attribute. So instead of needing to write message equals message, which is repetitive and is against the concept of Svelte having terse and concise code, we can just shorten this to message. And this doesn't look very powerful yet, but think about having multiple properties that are passed into a component. So then you're saving a lot of lines of code actually. So when I go into the child, we see it's again a TS script block and we're receiving the message from the parent by saying export let. So in this case, the export syntax is actually kind of misused, but it works very well in actually writing code. So whenever we say export let, we can receive a prop from the parent. And this blue equals true, on the other hand, is a local state. So we can see this is another shorthand attribute, in this case for setting the class. So when the value of blue is true, we can also set this blue to be applied to the button. The next example that I have for you is about global state management. So if you think about other libraries like Angular, React, and Vue, you always certainly need a third-party library like, let's say, Vuex or also Redux, which is complicated and probably takes you like 1 or 2 months to learn. But Svelte has the concept of stores already out of the box for you. So here we can see that I have defined a stores.js, which has an isDef state for us to be used. And the way we do this is we have this writable from Svelte store module. And here I really only have this isDef state that is checking if the node environment is development or if it's something else. And so we're importing this. And here we have to use the store with a $sign in front of it to actually subscribe to the store, which could change values in between. And Svelte also handles the unsubscribing automatically for you. So there won't ever be any memory leaks. And we can see on the page that we are now showing this paragraph in development mode. And if I come to the terminal here, which is running Svelte kit, I will run the production build for a moment. And you will see this is super fast. So it's running our production bundle in not even 6 seconds. And with yarn start, I can actually run it. Oh, wrong screen. And now you see it already refreshed for us in the background, and the paragraph is now shown for production mode, which is this part. The next example that I prepared for you is about async await or promises in general. So we can see here that I have a click count that is 0 initially. We have an async function of just getting a random number with math_random. And if our click count would be more than 1, we would reject a promise. And otherwise, we would just fake a promise here and resolve the value of math_random after 1 second. And on handle click, we would increment the click counter and refresh the promise. And this is actually the syntax that I want to show you. So instead of having to set separate states for loading, error, and also the resolved state, we can just have an await, a then, and a catch block in Svelte, which would be the equivalent of that. And to show you this, how it looks, it would look like that. On the initial mounting of the component, where we already saw the waiting and now the promise was resolved. If I click once generate random number, we're again landing in the loading state and then resolving it successfully. And if I click once more, we see that we're landing in the too many clicks catch block because we clicked more than 1 time. Yeah, since Svelte is actually used for animations and complex data visualizations, this is definitely one of the strongest points of Svelte. So here we're importing the spring animation from the Svelte motion module, and we're setting coordinates to 50x and 50y, and we're using the configuration options for the spring store with stiffness and damping, and also setting an initial size of 10 for the size, and then having an SVG where we have some event handlers on it. And yeah, to actually showcase you what this is doing, I created this example, which is behaving like a basketball, for example. And you see there's no performance issues at all. It's re-rendering super smooth. And if you were wondering like who would ever use this in a production application, I actually have the perfect example for you. So this is one of the client websites that I was working on, and you can see he was demanding that I implement the cursor to be a dot, and when you're hovering over links or when you're hovering over buttons, that you would have this kind of animation. The last example that I prepared for you is about transitions, and this is not as flashy as the jumping ball, but transitions is something that is often a requirement in a day-to-day development. So here we're having a fade animation that is from the Svelte transitions module, and we have the should fade in, which is initialized with false. We have a button that is toggling this should fade in value, and if we actually want to fade in, we're looping here just over 5 numbers, and this will generate us 5 different p tags with an incrementing duration. And again, I want to show you how this looks. So here we have this button, and when I click it, we will have a kind of staggering fade in of 5 paragraphs with now you see me. And the same also goes in the other direction. So you see here, the first one will fade out the first, and then like that. Yeah, and another thing that is really cool about SvelteKit here is if I empty the cache and hard reload, you will see how small the bundle size is here for the production application. So we're really running here only on 30 KB that are transferred over the network with a total of 9 requests. Yes, this is a small application, but in the end, there's not many frameworks who can go down to a total size of 30 KB. And this is great for users who don't have such a great internet connection or who maybe have a metered connection. So that's also one of the strong points of Svelte. And if I go back to my slides, now you saw a lot of positive examples about Svelte, but I always want to be fair and also consider what's not so great. So one thing that is holding back, I guess, also a lot of other developers from using Svelte is that the development speed and decision making is just not up par with the bigger libraries that are out there. There's no corporate backing, and it can sometimes take a while for PRs to be merged. But this will hopefully also change with an increased adaptation of the framework. And one downside that I see with Svelte is just that it was simply created later than React, Angular, and Vue, which is a disadvantage because these libraries were already created at a time where there was a need for a good web application framework. And Svelte is now coming at a time where they already took the major share of the market. Another disadvantage is that there is a lack of available jobs. This would also change, of course, with more adoption of the framework. I was lucky to find free client jobs through the Svelte Discord jobs channel, and there's also sveltejobs.dev in case you're looking. If you plan on building a big enterprise application with Svelte, you might be lacking the necessary tooling for it, depending on the scale of the project. In my case, I built a 30 pages plagiarism checker application, and I always found enough third-party libraries that worked really great. You can find everything that is released on madewithsvelte.com. If you decide to start a project with SvelteKit in this case, this would be my recommended tech stack. So as soon as SvelteKit would be stable, you could definitely use this. So you're already set up with routing and state management out of the box. No third party is necessary. What works really well for me is the Svelte Forms lib. This is also actually a wrapper around Formic. There's also solutions for date pickers, drop zones, and I can really recommend using Svelte and SvelteKit with the UI library Tailwind CSS. I'm nowadays writing all of my CSS with Tailwind, and you kind of have Svelte, which is optimizing your JavaScript. And on the other hand, you have Tailwind, which takes care of purging your unused CSS. So this is a really powerful combination. Yeah, and there's also solutions for toasts, unit testing, and internationalization. Yeah, this is a word cloud about companies that are using Svelte in production currently. So of course we have New York Times here because Rich Harris works there, but there's also other big names like IBM, and they even wrote a UI component library called Carbon Components. And there's also names like Apple here that is actually actively looking for contractors and also full-time positions. For the future of Svelte, I see a great potential. So SvelteKit will be released as a stable version quite soon. And it contains all of the latest development tools like Vite from Vue.js founder Evan You. It's using native ES modules under the hood. It has instant hot module reloading, and it's doing dependency pre-bundling. So this is really bleeding edge, a great workflow, great tooling. And I also see that Svelte will have increased backing and support by companies and communities. There is also an open collective where you can donate and sponsor the project. And I see a great potential also that Svelte can win over developers one at a time, because in general, I feel like developers are fatigued by the front-end complexity and boilerplatiness of it. So that's definitely a strong point. And I think Svelte could take over Angular in popularity quite soon. So currently Svelte is ranked as the 4th most popular front-end framework based on GitHub stars. So we will see about that. I also linked you some helpful resources in my presentation here. So this is the source code for my talk can be found on my GitHub repository. I actually wrote a blog post on Medium about the exact same topic, and this was the idea for holding this presentation. Yeah, and then there's some other resources that I can recommend you to take a look at. If you liked my talk, let's connect. I linked you my website, LinkedIn, and Twitter profiles. And as a conclusion, I would say reflect on your current developer experience. Are you happy with how you're coding currently? Is there anything that is bugging you? Do you think that there could be a better way of writing certain things? If you say yes to that, then definitely go and work through the Svelte tutorial. The link is here for the tutorial. If you become a fan like I am, then I would definitely recommend you to join the Discord. The invite link is there. It's a small but great community. And yeah, I would also recommend you to if you decide to adopt the Svelte, that you use Svelte at work and also in personal projects. Thank you for your attention. Now it's the Q&A section.
Yes, thank you, Marcus. So we already have a lot of questions coming in. So I'll just jump into the first ones. Claire is asking what router library you are using.
This really depends on if you're using Svelte or SvelteKit. So SvelteKit has this out of the box for you. If you decide to use Svelte without any framework on top, there's different versions, like there's Svelte routing, there's Tinrow, there's a lot of routing libraries out there. Depends on if you want to have it based on the file tree, or if you want to have it kind of like React Router, where you can just define wherever your routes are.
Okay, then TypeScript Freak is asking if Svelte supports TypeScript.
Yeah, definitely. I think Svelte supports TypeScript since May 2020 or something like that. So it's already stable, and like I said before, SvelteKit also has TypeScript support built in.
Then the next question, I mean, you have already showed it, what popular websites are made with Svelte, so there was already some, but maybe you want to repeat it?
Yeah, I can repeat it. So there's definitely some parts of New York Times are written in Svelte. There is Alaska Airlines, there's IBM, there's Apple. So there's a lot of big names that start using it but not promoting it yet. I guess they're also quite trialing it, let's say.
Okay, and then the next question, did you use Zappa for your client projects? If yes, what are your experiences, Zappa versus Gatsby?
Yeah, so I think Gatsby really has some issues with starting up. So it's a slow startup, and I notice every time compared to Zappa that it's taking a while to start up, and it's just doing so many things before even running the development server. Yeah, but I mean, you can't really compare it because with Gatsby you have GraphQL out of the box, and you have some other things. And Zappa, I have like 3 or 4 clients that I have projects with, and they're all happy whenever I show them Lighthouse score of 100%. So yeah.
Okay, thank you. Bilyal is asking, does props auto-completion and typing come out of the box with SvelteKit?
Yeah, since it's using TypeScript, it also has the auto-completion for that, and there's the language tools repository for Svelte, and there is a lot of work going on, and pretty much every day new releases. So a lot of things are happening.
Thank you very much. Then simple question. I hope a simple question. What code editor do you recommend?
I use VS Code for everything I do, and I'm really happy with it. But it depends a lot on the language that you're using.
Then a more specific question, is mutation in store supported?
Yeah, I mean, there is you can always there's an operator .set on all of the store elements, so you can always override the values that you had before, and then it's also automatically reactive and fetching you the new values. So for example, if you switch locales, this is one way of how it's handled, and it's instantly refreshing the view for you.
Okay, and to one question, one comment left. So the last question is it possible to use Webpack? I think so, right? It was.
Yeah, so Zapper and also SvelteKit support Webpack and Rollup out of the box. You have to switch, you have to decide basically between which template you want to clone, but it's really recommended to use Rollup because it's the project of Rich Harris, so that's his personal favorite, and it's also having some advantages over Webpack.
Okay, and then there is only a comment. I think it relates to the very beginning of the presentation. So it's saying, as far as I know, the Angular IY compiler also compiles to plain JS without making use of virtual DOM. So if you want to say something related to that, if not, then not.
I actually stopped using Angular shortly before Ivy was released. So I think Angular 7 or Angular 8, I don't remember. So I don't have a detailed viewpoint about this, but I think Ivy is definitely a big step forward also for Angular to deliver smaller bundles.
Okay, Markus, that was already the last comment. I think people have enjoyed the talk very much. So I hope to see you also in the future again at the event, also when Svelte also gets even more mature, and maybe we can get some updates from you on the progress. So that would be very nice.
Yeah, thanks for having me. Definitely looking forward to it.
Thank you. Bye-bye.
Bye.
So, dear developers, it's already the third day. It's also becoming a bit late. You also see that we lost some of the templates in our OBS setup, which is why we had to change a bit the arrangement. So I would say that was our last session. It was a great event with 3 days, a lot of speakers, a lot of cool insights. I hope you enjoyed it as we did. Thanks again to our partner of today, Vinted. Thanks for making this event possible. Thanks also to John Collins again for moderating the first half of today. And thank you for watching. One last thing, but not least, if you are looking for a job or if you want to scan the market, please visit WeAreDevelopers.com. You will find there a lot of jobs in Europe, a lot of them already with upfront salary information, so take use of that. Scan the market, and other than that, we will move on with our next events in a couple of weeks. So in April we will have the Android Developer Day and the iOS Developer Day. So everyone who is interested to learn something about mobile app development, please join in April, stay tuned. Subscribe to our newsletter, register on the platform WeAreDevelopers.com. Follow us on social media, subscribe our YouTube channel, and just stay connected with us. And with that said, thank you very much for watching. Stay healthy, stay safe, and see you in 2 or 3 weeks again. Bye bye.